Okay. Oh, I'm very tired. Oh my. Okay, new setup. Yeah, I don't know what to say. I went and got this camera yesterday, literally after the stream, because I was like, I don't know. I just wasn't feeling the quality of the video. And I was like, maybe it'll take like it's not a huge investment compared to the investment I'm about to make in a few days. But it's a pretty good investment into this camera. I was like, you know, maybe that'll like push me to be a little more consistent and kind of continue doing this. And so that is that's the plan, Stan. And so I think I'm good though. I think I got everything squared away and set up the way that I want it to be. I'm using the Logitech C290X. Pro. Let me remember to put this in the description just in case, but so far it's pretty fire. I think I really enjoy the customization on it as far as like specs go when it comes to, or not specs, when it comes to like configuring the video. Being able to play with like the white balance, the hue, the saturation. I think that stuff is pretty cool. So hopefully the mic is substantial. It's not trash. But it's in the description, which I will be referring back to. If I'm looking over here, it's because it's the other monitor. But it's in the description, which I will be referring back to, so that I can remember what we're supposed to work on. And I really want to play, like I have this specific music that I really like, but low key, I don't know if it'll copyright. Let me see. For personal use. Yeah, they basically said it's just for me, I guess. So, that's fun. I really actually enjoyed Brain FM too, not gonna lie. But here's what it is. In that case, I'm trying to think, because the audio input is coming from the Logitech camera. I could do it to where only you guys would hear the audio output. And I'm on a desktop computer. So, and my desktop is not the most compatible thing in the world with Apple products. That's why yesterday I was able to like share my, iPad screen. I'm not gonna be able to do that today. It's not gonna be possible. Yeah, we'll see. But then if I play the music out loud, here's what I'm thinking. If I play the music out loud, it's gonna be like, oh, unless I mute desktop audio and then play it. Oh shoot. Code Academy, that's so funny. Let me see if you can hear it. I think you should be able to. I'm really not sure if you can though. Hold on, let me check. Freaking Brain FM. Okay, let's see here. It's faint, but it's gonna do it, boys. Shut the hell up! What the hell is going on right now? Okay. Okay, let me put this in. Well, no. Okay. Okay. I'm so hungry. Turn off my phone. Verse of the day, Matthew 5:9. God blesses those who work for peace, for they will be called the children of God. Yeah. Holy crap.
Or us as an ice cream shop connecting.
No. That's where you lost me. No. We might just be doing this in silence, low key. Let me stop. That's a little frustrating, isn't it? Oh, wait. That's a bit frustrating though. I know what I could do. Yeah, we could do this. Okay. Now I'm gonna go get a coffee because I need a coffee. Yeah. Okay, that might be. Well, maybe not because. Okay, let me get some. Oh my gosh. I don't even know if you heard that, but my stomach just. She didn't even growl, she just screamed at me. So I'm gonna get some coffee and I'll be back. I feel a lot better. Oh man. Alright, let's start. Like I said, you won't be able to see my iPad. Where have my earrings disappeared to? That's not good, guys. One second. That's not good at all. Oh shoot. There they are. Oh gosh. That gave me a fright. That was a bad scare. Goated pen, Muji. I want to get a Rotring pen. That's not a Rotring, but I want to get one for sure. Well, let me turn this down a little bit more. Actually, no, I think it's fine. But where's my black one? What the hell? Oh, it's right here. But yeah, all right, wait. Gotta give a quick update. Alright, quick update. Even though it's not an update, it would be an intro because you didn't even know I read the book. I just finished That's gonna be flip for you, isn't it? The things I do. Oh, I know what I have to do. I'm getting better with this as time goes on. Hold on, let me see. Bet. Okay. Jeez. I have to tilt like this. But it's called the Bill Hodges trilogy. You'll come to learn, but Stephen King is... There's no way there's a freaking ad on live music right now. Oh, I'm gonna cry. There's only one thing left to do. Holy crap. I'm gonna go to freaking Apple Music. But, he's my favorite author, for sure. Yeah, he's definitely my favorite author. And no, I haven't read it. I'm not into clowns and stuff like that. It's really scary. I have a threshold. And some of the stuff he talks about is really scary. But it's like thriller, horror scary. So like I'm okay with that. But it is a whole, a whole nother can of worms. I don't know. But I just finished it last night. I think I had like 100 pages left, and I was like, just knock this out, because I have other books. I got this from the library, because I was like, I read the first 2 books from my college's library. I don't go to Palm Beach State College. I go to Mercy University. So I read it from Tarver Library, their library, and it was really good. But then I had to like start leaving and stuff to come home, and so I got like 25, 40, that's a big difference, 25-30% through the 3rd book, and then I had to leave, so I had to return it, and then I just never like came back to it. I think I was in like March or April, and so I went and got this maybe like last week. So I went and got this. I got like a Physics for Dummies book, Statistics for Dummies, because I need to review both of those. I went and got a bunch of books. So I definitely want to try to start reading books from the library prior to purchasing them for real. So now I've read the whole thing. And because he just came out with a new book, this is how I get off task. So we have to make sure this doesn't happen. So we're gonna start at 6 a.m. promptly. But yeah, I was gonna freaking email him and be like, dude, you're such a goat. Such a freaking goat, dude. But let me see. I think it's Don't Never Flinch. So this is the one that I'm probably gonna go and get from Barnes & Noble Maybe I'll go get it like this upcoming Friday. But I have this book. I have like a special, I think that's what makes it tough when you have a special edition book, because then it's like you walk around with this thing that looks like a majestic Bible. But let me see if I can show you what it looks like. Cause I walked into freaking Barnes and Nobles and got the special edition, and I was like, ooh. And now I freaking have a book that, this is literally what it looks like, and it's huge as hell. And I was like, I'm not carrying that around. So I've yet to read The Stand. But I've read Pet Sematary. Oh wait, no, I have not read that one. I read Outsider. Carrie was his first one. I want to read Never Flinch, because the same main character in that book is Holly, and Holly got her like start in these books, but I don't know, I guess it's like reverse, because I read the first book I ever read by Stephen King was The Outsider, and the main character was already like tenured, like in her thing that she does now. And so then after reading The Outsider, I was like, oh shoot, like I really like this person. And then he came out with Holly, and then I read that too, and I was like, dang, I really like this person. And then that's when I was like, I believe I researched it more, and that's when I found out that this is where she was introduced in like this 3-part trilogy, and I was like, there's no freaking way. So it's like seeing a character when they've already like blossomed, and then going back and like reading about their failures. It was actually pretty cool. Or like how they came to be in the story and stuff like that. It was pretty cool. So I read that, read Holly. I did read You Like It Darker. It's just a bunch of short stories. This is 11/22/63 is by far the best book I've ever read, for sure. It's top 3, for sure. That's book 1. This is what I read. I read If It Bleeds. I read Billy Summers. My teammate got me Tommy Knockers. I haven't read it yet. And that's pretty much it. But he's such a goat. Such a goat. And yeah, he just released Never Flinch. So yeah, I'll probably go get that. Yeah, like Friday. I have some other books I want to get, like Classical Mechanics, this textbook by Taylor and, no, it's just John Taylor. I want to get this book, so I need to order this. I don't know when, but I do order it soon. Because what I'm also going to do today is start, I'm also going to start like an MIT physics course. Because I didn't take physics for this summer, but I kind of want to take physics. So through MIT's open courseware, I'll take physics 1 or classical mechanics. Yeah, that's the plan. But I have like 9 minutes. I just finished reading this. It was really good. I didn't have a bookmark, so I used the parking ticket I got in Miami as a damn bookmark. But that was really good. Next book, I'm really trying to prioritize math books. This, I haven't read too much of it. I've read up to like this. Wow, that's bright. You can't even see it. Yeah, I've read up to there. But it's How to Solve It by G. Polya. Such a, like, it's so good. It's so good. It literally teaches you how to solve math problems, not just from the perspective of a student, but from the perspective of a teacher, where you're like, okay, we have this almost probing kids to get to the answer themselves, so they feel that they made that accomplishment, you know? Such a good freaking book, truly. But I have some more books from the library that I gotta. Oof. These are the other 2 books I got, so I have to read these. Fundamentals, 10 Keys to Reality by Frank Wilczek. But I'll probably read this one because it's just a little bit smaller and I could probably get through it. I could probably get through this. I could start today and really get a good bit through it. I think it'd be good to read this while I'm doing physics. So, and again, if I like the book, then I just go out and buy it myself. And then, because I really like to annotate books and like mark in them and stuff like that. Hold on. Yeah, I really like to annotate books, mark in them, and do all that. But of course, you can't do that with a library book. So, fiction books I don't annotate in. I just like to read. But non-fiction books I like to stop and slow down, stuff like that. And then I got Proof, which is a book about, well, proofs. And it says how the world became geometric. It just seems so interesting to me. It talks about Euclid. I'm sure it's going to talk about Euler. Oh, it goes into a long history of geometry and like things that you see on the everyday basis. I think the biggest, one of the biggest, I guess, geometric examples is like a maze, you know? And this is funny because the front cover, now I'm looking at it, I just did this in, I use Brilliant.org, and not sponsored, what? I feel like every STEM channel is damn sponsored by Brilliant, but not me. And Codecademy. And in Brilliant, we're learning about underestimation, overestimation, and calculus, which is just Riemann sums, where you're trying to, I just learned about this yesterday, the technical definition of it, but trying to fit shapes that we already know the area of inside of irregular shapes whose area we don't know. So, yeah. Probably start reading this one first. Yeah. So that's that. And then I have a lot of, these are all research papers. Research papers and Calc 2 notes from a friend of mine who's also going to a different school, but somehow we ended up doing the same like community college course. It's crazy, but his started like a month ago, so he gave me some notes. But these are all the research papers. I'm not gonna read today, of course, but I will put in the description which ones I read, and hopefully I can get the link to them. Some of these are essays, like Richard Hamming's essay. So many freaking papers, and it's so light. It's such like a, hold on, because this is so, wait, can I change this? Looks like I'm surrounded by darkness. It's fine though. Can you see it now? That's so freaking bad that you can't even, hold on. I think that might be something with the lighting then. So, we shall. I think that makes it a hell of a lot better. Only one way to find out though. Oh my god. What the freak? Well, I don't know what to say, but whatever. I have 2 minutes. Last 2 books I got, Stats for Dummies and Physics 1 for Dummies. Which Physics 1 has been actually pretty chill. It's been pretty fun. And Stats. But I want to do experiments too, so we're gonna look into that too. I don't want to like blow up my house, but see how I could do like some experiments or something. No clue. These are the books I have. These are the piles of papers. I'm actually gonna clean up. And tune in because new Apple product coming in soon. Can't tell you what it is yet, but new Apple product coming soon. Because I can't keep listening to stuff out loud. It's driving me crazy. I'm not gonna be able to do it. Let me see if you can see stuff. Okay, clank. Cheers. All right. And like this. All right. I also have the Calc book. Shout out Professor McElwain for, bro. Oh, okay, I could just start doing it like that, but so I need to go through this. I think this is Calc. Did you say this was Calc 2? The derivative as a function, volumes. Oh, I see. Yeah. What is that? Differential equations, separable equations, tangent planes, and approximations. I think she gave me 2. Oh shoot. Sorry. Wait, preview of calculus, functions and models, 4 ways to represent a function, mathematical models, limits and derivatives, differentiation rules, applications, integrals, applications of integration, differential equations, PDEs, infinite sequences and series, vectors in the geometry of space, vector function, multiple integrals, vector calculus. This literally goes over everything now. I might just buy her a new one and just send it to Mercer too. Let me see how much this costs. She's so like cute and corny. I'll tell her I'm probably gonna get her a new text, so she'll like just give it back to me when you see me. Like what the hell? So cute and corny, man. I low-key want this one. This is another book I have. Just have freaking books all the time, dude. The Real Analysis Lifesaver. It's actually been pretty fire, I'm not gonna lie. Like I started watching Harvard's. Like this is what I like to do. Oh my gosh, I'm gonna get pissed in a second here. Oh my gosh. Wait. Let me see something. I don't make it too dark though. Bro. What the freak is this? Well, I hope you can see it, but that's how I like to. This isn't helping. Okay, there it is. But Yeah, I started watching Harvard's Math 55A lectures. To like really understand contrapositive, contradictions, direct proof, proof by induction. I'm trying to brain dump. Contrapositive, contradiction, proof by induction. I think they might be proof by deduction. Might be one too, maybe not. There might be some more. I learned the proof of even numbers. Maybe I remember it, maybe I don't. Yeah, for all, for every. Also, like learning the symbols. Like implies or implies if and only if. It's very interesting. Subsets, set theory. So it's interesting. This is another book. But yeah. So without further ado, 6:04. Let's get started. So this is like such jolly music. Hold on, I'm gonna plug my coffee up here. I also want to get a lot of this stuff off my desk. If I need some more integration problems though, I'll probably reference that book. My textbook. For the course I'm in, we're using OpenStack's textbook, which is, I mean, fire, it's free, you know what I'm saying? So, I already did this. I'm basically... so this is what we're doing. Chapter 5 review. Use of... Okay, so I'm like... I think I already did these though. Oh wait, no. Are these the exercises? State whether the given sums are equal or unequal. I remember this. Okay, hold on then. Let me finish the chapter. And then, yeah, let me finish the chapter. How long is the chapter? Because I'm at, alright, let me bunker down, boys. Yeah, I learned how to stream, well, you already know I learned how to stream my iPad yesterday, but still, I didn't really enjoy how I was in such a fixed position. I wasn't really a fan. I was in such a fixed position, so, yeah. And I didn't really like the lack of space I had when streaming from my Mac, so I chose to move over. Alright. So I think we already went through all this though. What is that? Yeah, because I did that. Approximating area. This is kind of like where we left off. Yeah. That was for the one for 1 over x. That was the one I had just finished doing. Okay, what answer did they get? For n equals 4 intervals, left endpoints 0. Yeah, I got 0.7595, or I got 0.7596, so the rounded decimal. Well, that just lets us know the next decimal is greater than 5. And then for the right, 0.6345. Yeah, same thing, rounded. My initial reaction was like it probably sloped downward, because had it sloped upwards from left to right, then right hand endpoints would have been an overestimation. So this was my thought process yesterday. Or I was like, maybe it's one of those curves that like start like this and go down. But the end behavior, I assumed. Looking at figure, you can see that. Why the hell are the clicks so loud? Oh, that's so cute. Look, it's like it's a hand. What's this one? Oh my god, I feel like oh, that's so cool. This is the typical one, right? That's fire. Okay, sorry. I could do a custom pointer image. What? That's so freaking badass. Wait. No way. Hold on, because it freaking looks like I'm in the shadows, or like I sleep in the shadows or something. Holy crap. Alright, that's better. Okay, what the freak? What? I did not know this. Oh my gosh, I didn't know you could get like a custom cursor. How old am I? Oh my gosh. This is low-key cool. This is why I love technology. Like, you could do like little quirky shit like this. Like, dude. And the creativity is insane. Oh my gosh. Okay. I really just wanted to make it less loud, but you know what I'm saying? I'm not mad. I'm not mad whatsoever. To show a circle. Yeah, no, but I'm just trying to make it less loud. I'm not sure if I can do that though. I don't think I can. I might switch mouses. Let me see how this one sounds. Oh, hell yeah. Sorry, kids. Turning this off. Oh, shoot. You can't even see. But wait, hold on. Listen to this. Wait. Let me be nice. Okay, versus... Literally no competition. Shoot, almost dropped it. Yes, I know, Queen. I know what I did. Holy smokes. Golly. Okay. Oh, my bad. My fault, G. Yeah, this is so much better. Sorry. Sorry, Dell. Let me make sure I don't lose this, though. Alright, cool. So, continue on. Or continuing on. Alright. Yeah, changing to x, b minus a divided by n. Left endpoint, so this should be an underestimation of the curve. Another underestimation of the curve. The same curve divided into 8 subintervals. When n, so it's basically like when n is the number of rectangles or the number of subintervals you have under the curve as n approaches infinity, your area approximation gets closer and closer to the actual area of the area under the curve. Yeah, like we've gone from 8 and now we've multiplied it by 4 and got 32, and we can see we went from 7.75 units squared to 7.9375 units squared, so we can make an approximation that our area under this curve is 8 units squared. Right endpoint, same thing. It's usually so I'm learning that if the curve from left to right, I guess if it's in behavior, no, I'm not gonna say in behavior. If the curve from left to right kind of increases, then it seems like when you take right hand endpoints, it'll be an overestimation. But if it's decreasing from left to right, then the right hand endpoints approximation is gonna be a underestimation. Yeah, okay. Approximate area. Yeah, so you can see when the curve was sloping upwards, left hand was an under approximation and right hand was an over approximation. So we know that it's kind of like mean value theorem in a sense, where we have a some sort of upper and lower bound to our function, and we know that the answer lies somewhere in between, but we don't really know where. So we have to, again, have n number of subintervals approach infinity so that we can get a more accurate deduction. And you could probably like keep this going, but remember, the number of subintervals you have is the number of times you have to plug in the change in x into the function and then multiply by change in x. So that means they did this 4 times, they did it 8 times, and this is like, now okay, you're doing it 32 different times. So what you gain in accuracy, like, it's pretty a tedious process. But I'm sure there's I feel like there's another. And this isn't the one that requires you to take the integral yet. I can't remember what type of question. But there's one where you take the integral of this, so it'd be like 1x squared. And then you would find the left and right hand. I think that's Riemann sums. Because right now we're just in approximating areas. Yeah, right on cue. A sum of this form where it's f of x sub I as the height. Yeah, so now we're doing base times height. Oh shoot, I'm not in my account, so I can't actually sulks. A sum of this form. Whoa, wait, I think I missed something. Okay, definition of a Riemann sum says let f of x be defined on a closed interval A to B, and let P be any partition of A to B. Let X, or the change, or we could just say delta. Let delta X sub I be the width of each interval. Okay, and for each I, let X sub I be any point within from end of rectangle, or beginning of rectangle 1 to end of rectangle 1. I'm assuming is what they mean. Because when you, like, if we start at X sub I and we go X sub I minus 1, we're going like, hopefully that's backwards for you. I think that's forwards, so whatever. But you almost go like, I hope it's backwards. Just imagine I'm doing this backwards. Actually, I'll give a number. So it'd probably be like, if X sub I was 6, X sub I minus 1 would be 5. And that would, I guess, take care of the space or the change in X between the beginning of X sub I and maybe like the end of X sub I minus 1. But it depends. Because if X sub I minus 1 is in that first, X sub I would be our X value. X sub I minus 1 would probably be our X. X sub I is our Y. Yeah. Okay. We'll choose a regular partition. Oh, yes. I think up here was like 0.5. Yeah, 0.25 in this one. Okay, yeah. Left hand and right hand endpoints. Estimates seem to get better and better as n gets larger and larger. The same thing happens with Riemann sums. Riemann sums gives better approximation for larger values of n. We are now ready to find the area under the curve in terms of Riemann sums. Okay, we're gonna let f of x be a continuous non-negative function. Then the area under the curve y equals f of x on the interval a to b is given by the area is equal to the limit. We literally just talked about this, where n subintervals, or n the number of rectangles or shapes that we're using to approximate the curve. As we split them up into smaller and smaller ones, we go from n equals 4. We go from n equals 4 to n equals 8 to n equals 32. As this happens, the sum of our function occurs. Yeah, that's how we get the area. Okay. Sequences in series. So is the lower sum just an under approximation? So does this mean for the upper sum, a sum obtained by using the maximum values of f of x? Wait, so then they use 1.25, 1.5. I'm thinking if we do left, it'd be like this. Yeah, I think that's what it's gonna be for upper sum. Okay, let's do it. What exercise is this? Alright, okay. Oh shoot, no, we're in 5.1. What's x squared? 10 minus x squared. Okay, and the curve looks like this. So we would do left-hand endpoints. Yeah, that's good, because that's a, and we're doing it from 1 to 2. Yeah, that's an over estimation. Okay, fire. Alright, so we know change in x is going to be equal to So for this one, we're using left hand. Okay, so now we know that our area on the left hand is going to be equal to well, let's just do 0.25 all multiplied by 1 squared 10 minus. Should I do like that? 10 minus 1 squared? Yeah, okay. 10 minus 1 plus 10 minus. Okay. I got 32.125. What the? Oh shoot, I'm sorry, I forgot to multiply by 0.25. That's on me. Okay, yeah. I got 8.0313. Yeah, my fault. Okay. Oof. Trig. Oh, that's fun. Find the lower sum for f of x equals sine x. A lower sum for f of x equals sine x over the interval AB is equal to 0 to pi over 2. So this is like 0 to 90 degrees now. I think that's what pi over 2 is. Yeah. And let n equals 6. So, oh, okay. So then we would do pi over 2 divided by 6. Okay, the intervals are 0 to pi over 12, pi over 12, pi over 6, and 5 pi over 12 to pi over 2. Okay, yeah. So it moves in intervals of pi over 12. F of x equals sine x is increasing over the integral or the interval 0 to pi over 2. So left hand endpoint approximation gives a lower sum. from 0 to 5. So it's left-hand endpoint starting at pi over 12. Oh wait, no. Oh, yes. So 1, 2, 3, 4, 5, 6. Okay, yeah, because this is changing x. Okay. Okay, so dibba-dibba-doo. Dibba-dibba-doo. Okay, fire. Where's the interval? Oh, pi over, no, 0 to pi over 2. Oh, wait. Because wait a minute. Oh, you know what I could have done? What in the hell was that? Oh my. Wait, no, that doesn't. Oh my. Where the hell am I typing if I'm not typing here? I'm confuzzled. What the freak? Hello? What the freak? That's why. This isn't just for the mouse. Let me make sure I don't accidentally pull the webcam out. That makes so much sense. That really does. Yeah, that makes an insane amount of sense. Alright. Excuse my typing. I'm gonna say that for forewarning. I try and use ChatGPT as like a resource, but I try and brain dump to it first so that it's not giving me all the answers. It's like, okay, this is all that I know about this problem, but here's where I'm stuck. I mean, I don't really ask it to always give me the answers. Sometimes I'm like, just probe and like ask me questions so that I get the answer. But anyways. What's the equation? What? Yep, there it is. What did I just write? It's A. I didn't even include the 0 because I was like, it's just gonna be pi over 2. Yeah. That's what I did. No, I pulled out pi times 1/2, which is actually quite the same. Okay, so I was there. Okay, good. Okay, fire. Oh, I could do it like that too. Yeah, that makes sense. Alright. I don't remember who told me that trick where if you have A divided by B and all of that's divided by C, you could just take A out and then multiply B and C. Or I think it's, yeah, you just multiply B and C. And take them both to the denominator. Okay. Okay, so boom. So now we have our change in X. And we know that our curve looks like that. So now we're gonna do right hand. So I'm actually no, because this is something completely different. Yeah, we're doing left hand. So and then our intervals 0 to, is it pi over 12? Okay, so now we have to get the say okay. Okay. So we're looking at pi over 12 multiplied by sine of pi over 12 plus sine Okay, let me not forget this time to multiply by pi over 12. Alright, let's do some math. So sine of, damn it, no, okay, sine of pi over 12. Should I just do all of them? Or two at a time? Do two at a time. Actually, no, I'm not. I'm actually going to separate this. Okay, I got 1.1252. Yeah, I gotta remember to put the units though. Units squared. Okay, the use of sigma summation notation is useful for expressing long values of sum for a continuous function. Oh man. This is the one that I'm like, where am I gonna see this one at? This bottom one. Because they didn't show like an example of this one. This is for I squared, I cubed, left endpoints. I also have to remember to start at 0 when it's a left endpoint approximation versus a right endpoint approximation. Which for left, starting at 0 just means make sure you include 0 when you're, I guess, highlighting your intervals. This music makes me feel like I'm gonna go frolic. I'm not gonna lie. It's like, you know. Hold on. I think I'm gonna change it. Oh my gosh.
Learn Spanish with real Spanish TV.
I freaking love La Casa de Papel, Money Heist. Oh my gosh, I just finished the last season. So good. It's so good. Love Money Heist. I freaking love these. Like the classical playlist. It makes me feel like any second now Einstein's coming back. Alright, glossary, left endpoints, regular partition, Riemann sum, right endpoint, sigma notation. Oh my gosh. Sweet baby Jesus. We finished. Jesus. What is that? End of... It actually wasn't bad, I'm not gonna lie. But I feel like it's review. I remember we learned Riemann sums in Calc 1. So, it wasn't too bad. Alright, that's 5.1. Now, the exercises. I'm actually gonna go on there. Yeah. Can I just do all of them? I'm not gonna do all of them. I'll probably do... probably print it and do it. I like doing problems on paper though. What the freak? There's no way they printed the whole damn book. Please. There's no way they printed the whole damn book. There's no way. I just wanted the... No. I just wanted the PDF of it. Please, sir. Okay. Wait, so do I just have to... I'm confuzzled. So how do I know... It's okay. Yeah, that's what I just finished. Okay, so here it is. What is this? Page 583. And we'll do like 584. Okay. Low key, yeah. While we wait. Do a wee bit of shopping. I also want to get into typing, but like, you know, like practice and actually do it for did it do it? Okay, bet. That low-key scared me, but I don't know why. I mean, I click print. I really want the math books. I mean, these are math. These are GREs, which I don't know when I'll start prepping for my GREs, because I do want to go to graduate school. I think we just ran out of ink, guys. Damn it! Damn it! Oh, just kidding. Just kidding. It was paper. We ran out of paper. Alright. Now I need a napkin to clean that up. Just clean up my sleeve. Holy shoot. Sorry about that. Didn't mean to cause an earthquake. Alright, I'm gonna go through and do these problems. And then we'll move on. I don't know if there's a way to like get you to see them without. This is so damn bright. I mean, I guess. I mean, the sun's coming out, so like. Oh, oh shoot. Yeah, so. Let's see if I can darken this so you can kind of see what the hell is going on. I'm gonna have to figure this out. Later today, because I don't want to have to like keep. I want to do auto brightness, but it like won't let me. and I have no clue why. Like, look at how dark I have to put it for you to see what the frick I'm doing. That's cool. It's fire. Alright. Oof. Plus that on that, so. And I don't have to keep this up. That's whatever. Okay, well. Alright. Calculator. State whether the given sums are equal or unequal. So if we do, that's n plus 1, so 10, 11 divided by 2, basically compared to 15, 16 divided by 2 minus 5. That's basically what we're evaluating. Alright, let me get my, where's my eraser? Hold on. So I want this to be a certain way. Okay. What did I just say? I said 10, 11, 2 is equal to that. And then over here we would have like 15, 16 divided by 2 minus 5, 15, which would be equal to that. So I'm getting 55 here. Oh wait, no, I think because, hold on. Yeah, and then let's do, and take and subtract, then divide that by 2. Let me try the other way, see if I get it. Because, you know, depending on what way you do PEMDAS. Or unequal either way it goes, but I think the first way is the correct way if I remember. Because they're originally together. So that's why it's 15 times 16. Sugar. 15 times 16. Okay. This next one. I feel like I could, I don't even know if you could see, but I feel like I could distribute this and have like a j squared. So then it would be like basically I squared minus I. I'm trying to do this as efficiently as possible. Okay. I think we could do I squared. Hold on, because I low-key, I guess, have my doubts. Because I remember seeing a similar problem like this. So This one wasn't it, but that's kind of my thought process. Oh my gosh. Boy, Wolfgang is going stupid right now. Hold on, my boy. Whoa, whoa, whoa. Whoa, whoa. Okay. It wasn't this one. You can break this expression in 3 terms. Actually, it kind of was that one. Like, see, with this one, I just split it up. So I did 2k plus 1. I'm thinking we may just do the same thing and then multiply that number by I minus 1. Let me see what they did. Okay. See, and now we're getting into approximating. Where's the... I think it's at the end. Oh wait, no, it was right there. Because we have something like this. Basically. So they're saying that we can just treat that j as a constant. Or that I. That's what I'm gonna do. I'm gonna treat the I as a constant instead. So treating it as a constant would look like me bringing I to the outside and then doing like an I here subtracted by minus basically a 1 here. So, and we'll go ahead and solve that. So we're looking at 10, 10 plus 11, we know is, I think that's going to end up being 210, regardless. Or 11, sorry, 1110. So we get divided by 2, so we're going to end up with like a 55 here. And then we'll have a 55 here. And then we'll have minus 10. So then we'd have 55 times 45. And this would give us our answer for this one. Which I'm not sure how that's a large number. For the second one, we would pretty much do the same thing, but now we go from 0 to 9. That's interesting, because now, oh wait, when you go from 0 to 9, that's 10 numbers, but is it the same as going from 1 to 10? And how the hell do we start from? I think it should be the same. So we would have 90. So we would have like a 90. Oh no, it'd be 45. Because it'd be n times n plus 1. So 9 times 10. And then divided by 2, so it'd be 45. There would be a 45 here. It'd be plus 9. So then it should be you know what, I'm gonna put them on the opposite side. So to like mess with my work. Okay, last one. If this and this are equal, then that changes my perception about this and this one. So we can see. But if it's 10, then that should be no different than this one. And we'll end up with like 55. So we'll get a 55, 10. And then basically we'll get another 55 minus 10. Which would give us 45 times 10, which we did, which is going to be 2475. And then we're looking at k squared, which is going to be it's going to end up being 10 times 11 times 20 n times n, or sorry, yeah, n times n plus 1. I think it's 2n plus 1 is how it goes, and then it's divided by 6. Yeah, okay. Which is 20 plus 1, which is 21. I might as well do all the math while I'm here. So it's gonna be that, and then 10 times 20 plus 1 is 21, and divide all of that by 6, and that is k squared. And we subtract basically 55, because 10 times 11 divided by 2. Okay, and then this should give I got 330, which really now makes me question this one. Because if it would have been I squared minus I, then they would have been the same. So this will tell me a lot. These D and C will tell me a lot. Because if I should have distributed this, I times I minus 1, then we're gonna see. Oh my gosh. Okay. Okay, so now I see. I'm gonna mark it all wrong, but I'll come back and redo it. So then that means, but see, I don't know where I went wrong with this. That's where I went wrong. I freaking started at 1. I was supposed to start at 6. Here, I just should have distributed. What is C talking about? Substituting J equals I minus 1. Here it started with 0. This is quite literally the same. And then you would basically get I squared minus I, which is the same as k squared minus k, all other things equal, which they were. Okay. Oh, there's no way the answer is right there. Whoa. I didn't even see that. That tells you how locked in I was. I didn't even see that. Why would they put the damn... It's okay. Num 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 num. I have no clue how I'm gonna cover that up. Let's get a brainstorm. Okay, I didn't see this one. So covered. Covered. And do I have any tape? Barely. Holy moly. I'm gonna tape it. I actually think I have more tape somewhere else, but this isn't even sticky. This isn't gonna do. Look at my moons. Y'all are like, what the frick is this? But arts and crafts. Oh, make sure I cover this one up too. Well, yeah, that worked out nicely. All right. Continuing on. Okay. So, you know what I could do? Because this really just goes from 5 to 10, if you subtract, like here, where I went from 0 to 9, did I use 9? I think I did. But this should have just been, I think I used the correct thing. But I can just subtract 10 from 5 to get the, what we're trying to look for. It would be the same, like, if I have a Riemann sum, like I do here, going from 5 to 10, I would imagine that's the same thing as having one that goes from 1 to 5. I'm gonna put a question mark because I'm unsure, but that's my, I don't know, that's my guess. So this is gonna be 15. Same thing, so this is gonna be n times n plus 1, so 5 times 6 times 11 divided by 6. So this is gonna be 30, and then we have 30 times 11 divided by 2. I think literally the same rule applies. Suppose that a of I from index 1 to 100 is 15, and b of I, so then this would be equal to, wait, it's addition, right? Okay, so this would be equal to 3. This would be equal to 27 negative. Yeah. Okay, we're still assuming the same thing, so then this would probably be 3 times 15 minus 4 times a negative 12, which would be 45, basically plus, because 2 negatives is a positive. Right, 2 negatives is a positive. This should have been a positive 27, because it's 15 minus a negative 12. So here it should be same thing, a plus. And this should be plus 48, which would be 93. 45 plus 45 is 94. 8 minus 5 is 3. Okay, same thing. It's a constant. Plus 4 times a negative 12. So now we have 75 plus a negative 48. What is that, like 33? 27. Positive. Okay, let's see. See, I didn't expect for them to, oh my lord. Which one is that? What the hell? Oh, hell no. Okay. Seems like I'm getting a lot of shit wrong, I ain't gonna lie, but it makes sense now. I actually know why these are wrong. So this should have been, so we evaluate at the upper limit, subtracted by the evaluation at the lower limit. So hold on. So this would be like doing 10 times 11 times 21 all over 6, representative of I squared, minus R 5 times 6. I'm sorry, I just did the wrong thing. I'm sorry, this should have went here. It's okay, I know what to do. 5 times 6 times 11 over 6, and this would be for I squared. And then we would do 10 times 11 divided by 2 for the upper limit, and then it would be 5 times 6 divided by 2 for I. That makes so much sense. So it's not that they're equivalent. That makes sense. Okay, let me see. It only gives the odds. That's fine. I got that one correct. So I'm assuming I got this one correct as well. Okay, for this one, what is that, 6 and 7? So it's only gonna give me 7. So then I assume I got 6 correct too, because I used the same method. Okay, use summation properties and formulas to rewrite and then evaluate them. So first, I'm gonna go ahead and, where is it at? By this constant rule. I'm gonna go ahead and pull out the C and then evaluate it. So I'm gonna use rules 2 and 3. Maybe. Hold on, it's light as sugar now outside. Holy moly. Where's that setting at that I just had? Was it brightness? It was not brightness. Was it contrast? I don't think so. Where's the setting I just had? Was it? It wasn't saturation. It wasn't gamma. It wasn't white balance. What the hell, Beyonce? Hold on. Let me close that like that. Alright, that's a lot better. Okay, but alright. So that's what I'm gonna use here. So I'm gonna pull the 100 out. Now I wonder, do I need to evaluate it at 1 as well? And then, or do I need to evaluate it at 20 and then subtract the evaluation at 1? Oh, my eyeball. So low key my thought process now. I think that might just only be when the index is not 1. So, I'm just gonna evaluate this as I would. So I would do k squared minus 5k which I probably could have pulled out here. I just need not get confused because this is another constant, so I could do 5. Good grief. I could do 5 like times k plus 1, and then I would probably get something like that's 20 times 20 times 20 plus 1 times basically 2n plus 1, so 41, all divided by 6. And let me not forget my 100. Multiplied. And then we take all that, and I'm subtracting this 5 that's going to be applied to 20, 21, 2, and then it's all going to just be added to basically 20 because it's 1 times 20. Okay, and then basically times whatever number I get, so because it's 2n plus 1, so 20 times 21 times 41 divided by 6. Okay, and then we have 20 times 21 divided by 2 times 5. So it's really going to be this number minus this number plus 20. So it's 18, 40. This is going to be yeah. Okay, so that's what I got there. For this one, same thing. So we're gonna have a 50 times 51 times 101 all divided by 6 minus a 2 with a 50 times 51 divided by 2. Those should cancel out, but yeah, 2 should cancel out. 51 times 101 divided by 6. Okay, then we have 50 times 51 by 2 times 2. Yeah, so we could have canceled them out. So then we get, what was the one for divided by 6? So we get 42, 925 minus, damn it, it just gave me the answer. I forgot to cover the answers, but it's good because I didn't even see it, but it's correct. 42, 925 minus 2550. Okay, yeah, so 4375, which is right. Damn it. I honestly forgot. My scissors, I feel like scissors are cleaner, so I need to, since I already did this one, I can get the bottom half of the sticky note. Okay, and then this next one is pretty lengthy, so I actually might need to, I definitely want to cover up the answer. Okay, I think it'll go. Nope, okay. Now it's covering up my question. Okay, that's good. And then this next one. Oh wait, no, this one is short. Okay. Two more. This is good because the answer to this one isn't even on this page. Holy moly. That was a lot. Okay. And we continue on. Alright, bet. Okay, these are the new ones that we're doing now. So it's, hold on, because I may have did this one a bit too. I probably can cut off the. Alright, see now we're going from, so now I have to evaluate it at 20 and at 11 and subtract them. So I need to evaluate it at 20, which is gonna be, 20, 21, 41, 6 minus. Oh yeah, that's right. 20, 21, 2. And that is gonna equal 2. I'm just gonna put the total. 770, and then I like a dot, and then we do it at 11, which is gonna be 11 times 12. $21, $22, $23, which is gonna give us wait, no, that didn't make sense. I reversed the order. I'm sorry. It's like, what the hell? Okay. Sorry. At 10, it should have been, or sorry, no, it's at 11. should have been 11 times 12 times 23 here, divided by 6 minus. Yeah. This one should have been multiplied by our constant 10. Okay. Wait a minute, hold on, let me make sure. Should be n times n plus 1 times 2n plus 1 divided by 6. So n times n plus 1 times 2n plus 1. Okay, divided by 6, and then 10 times n plus 1 divided by 2. Okay, wow. So it was really... So which I guess kind of makes sense because now it's 770 basically plus a negative. Wait, no, this should be minus a negative, so it's really just plus. So it's minus a negative 154, which leads us to 770 plus 54. Interesting. Okay, so now we have something that's going to end up being this. It's going to end up being 4k squared. So I think it's best to take the 4 out, do k squared minus the 100 that we take out with a k. And we can just evaluate this at 25, so we can do 4. And then we can do 25 times 26, 25 times 2 plus 1, 51 divided by 6 minus 100, 25, 26 divided by 2. Okay, let's see. So for 10 and 11, okay, so I got that right. Now we're doing left and right hand endpoints. Let ln denote left endpoints, sub n intervals, and let r of n denote corresponding right endpoint sums. In 12 through 19, compute the indicated left and right hand sums for the given functions on the indicated intervals. So you want the left hand for a 4 sub-interval or 4 rectangles for f of x equals 1 over x minus 1 on the interval 2 to 3. So it's 1/4, so it's 2.25, 2.5. Okay, got it. So my enter. Okay, so now we do this is for number 12. We do so what is this left? So let me do it like this. The area of the left, 4 is equal to 0.25 multiplied by 1 over, this is left, so do I have a highlighter? This would be left, 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 left. So 1 over 1 plus I'm just gonna put my answer right here. Don't have much room. So okay. Okay. Now we do number 12. So that's 1 minus 0 divided by 4. So it's still 0.25. This time it's cosine pi times 0.25 plus cosine of pi zero 0.25 0.5. Alright, I see how this is going. And then wait. No, that's not the answer. You know why? Because I didn't multiply by 0.25. That's the answer. And if you think about it logically, like, how is it possible that the area is larger than what the interval is? Okay, now we have, I wonder if I just do this times 0.25 and then feed that through cosine. Holy moly. I'm not gonna lie, I don't know if that's the answer. Jesus, help me. Oh, wait. They got a positive 0.25. I got a negative 0.25 though. How is it positive? Let me see. Cosine pi times x. See, I mean, enter anything in wrong. Pi times 0.25. Yeah, I have no clue where they got that. Because it would have been this. Those 0.71s should have canceled out. So it really should have been -1 plus this number. Yeah, that's it. And then wait a minute. No. Yeah, I got a negative. What did they didn't say that? They said the answer is positive. What? Okay. I have no clue what went on there. I might start or highlight it, and then I'll go ask my math professor from Summer Ridge, or Summer Ridge Law. It's my high school. I'll ask my math professor from Mercer. What the hell? happen there. Okay, so here we basically end up with changing x is equal to wait, 1, 2, 3, 4, 5, 6, okay. And we're doing left hand and right hand. So, does it mean left hand? So it's 2. And then, my green, where are we for right hand? It's getting super green. Definitely need more space for this though, but it's okay. I'll split it up. I have a good bit of, so area for the left 6 is gonna be equal to. Should I distribute my denominator where it has? Whoa. Where it's like 1 over 6. Bro, I don't know. I'm not gonna do it, I swear. So we end up with, for the right hand, 0.5 times basically 1 over, so that's 1, so 0.5 plus 1.5. Let me do this like this. So it'd be 2.5 minus 1, 1.5, and then do 1.5 times 2.5, which is, and then it's 1 over that. Okay. Okay. And then we have, that's 2. Wait. Why did I just do that? No, that's incorrect. Oh, wait. No, that was correct. Oh, shoot. Okay. Yeah, that was correct. Okay, now we have Okay, well. What the hell type of... I probably should have just did the summation myself. That's on me, because I just got the right answer. Might be. Okay. Alright, same thing but now we're on different interval, so... Wait a damn minute. Oh, okay. Holy moly. This is... Okay. And we're on these intervals. Where did I put my intervals at? Oh, okay. Oh, let's do it. Okay. Well, it's a constant, so we can just calculate it like normal. So that would be 1/5 is what, 0.20 plus, let me make sure. I was about to say, what? Okay, yeah. Okay, good. Then we have oh wait, sorry, I did that wrong. Because you're supposed to be doing right hand, not left hand. So we should have started with -1, which would have been 0.50 plus 0, which would have been 1, and that's where we left off. Oh, because it'll always be positive, that's right. And then 1/3, which is 0.6667 or something like that. Okay, so we could do 1/3. Oh, just kidding. It's 0.333. The lies you tell. This gives us 2.33 repeating per area, and then the area left hand. This would be 0.20 plus 0.5 plus 1 plus 0.50, which would be 2.20. I've been forgetting my units. Okay. So 2.20 should be our answer for this one. Okay. Oh, this is interesting. It's a function. It's a opened up parabola. I can low-key kind of see the answer. And we're going from the interval 0 to 2. Oh, then I don't think the function matters like that then. Just kidding. No, this is gonna be good. I thought about it, but then I was like, it doesn't really matter. Because change in x is still gonna be 2/4, 1/2, or 0.5, which is what I like to use. With that being said, the area of the right fourth is just going to be equal to, or let me do my intervals. If it's moving by 0.5, it's going to be 0, 0.5, 0.5 to 1, 1 to 1.5, and then 1.5 to 2. So for right hand, we're doing 0.5 squared, which is 1. So then we have 1 minus 1. So this is 0.5 on the outside. And this is 1 plus 1 minus 2, which is -1 plus 1, which is 0. 1.5, which is 3. 1.5 squared. No, it's 2.25. Did I get that? I think 1.5 times 2 is 30. Yeah, 1.5 squared. Okay, so now we have 1.5 squared, 2.25. So then 2 times 1.5. There it is. That's 3. Plus 1. So we really have 2.25 minus 4. So -1.75. And the last one is 2, 4, 4. So this is going to be 1. So then we have, well, we've got, I think it's just going to be 0.25. 1 plus 0 plus 1, and take that and subtract 1.75. Yeah, 0.25. Now we take basically half of a quarter. 0.125. Okay, so now for area of the left, we have 0.5, and we have 0 squared. Oh, just kidding. Wow, they almost got me. Almost got my ass. Wow. Okay, now we're in 8 intervals for the left. Which I don't know if we have enough space for that. You know what sounds good? Some Auntie Annie's from the mall. That sounds really good right now, I'm not gonna lie. It's 1, 2, 3, that's 4 intervals. So now we have to, instead of going by 0.5, so this is where n equals 4. If n equals 8, then that's, now we're going by 0.25. No, it's okay. For this one, with the left, it's 0, 0.25, 0.5, 0.75, 1. Okay. So 0 squared is 0, 0, 1. 0.25. But 2 times 0.25 is 0.5, right? And we take that and we add 1, so it's really this minus 1.5. So we get a negative 1.4375 plus 0.5 Okay, so 0.5 I had already done. Over here, it was the first one. So that's gonna be 1 plus 0.75 1.25 damn it. Huh? I hate when things are fishy. Alright. That's 1. This should be 0.25, 0.5. This should be 0. Oh wait, no, just kidding. No, I'm cap. So then what? So this should be 0, 0.25, 0.5. Yeah, this one should be 0.75. 1 should be the second one, which is 0 plus. Yeah, we're at 1.25. Interesting. Okay, well. Okay, 1.5. And then 1.75. Hold on. Okay. That was fun. Where were we? I gotta calculate this stuff now. Yeah. These negatives are interesting as hell. What is that, 18 and 19? More specifically 19. Where are they getting positives from? Oh shoot, wait. No, I missed something. Wait. JK. So I did all those. Okay, so now I need a +1. And then minus 1.4375. That still doesn't help. What the hell? Wait, let me try this over. Are you shitting me? Okay, it's fine. 1 plus 1. Yeah, I got negative 0.25, so low key, I'm like, what the frick happened? I think this just got a little too junky, I'm not gonna lie. But 0.6875. There's so many numbers, like my eyes hurt, low key. I might just need a bigger sheet of paper to calculate this on, instead of this small, tiny sheet of paper, or like a sticky note or something. Because it would have been 2/8, so it would have been 0.25 delta x. Here. And I'm actually going to come back to this. Do it on a blank sheet of paper. I'm also not really understanding how they're getting positive numbers and I'm getting negative numbers. That's not really clicking. Compute their average value. I have no clue how to, like, where to even start with 2021. Well, it'd probably be 3 minus 3 plus x and 3 minus 3 minus x, and then compute their average value of 3 minus 3 plus x and 3 minus 3 minus x. And then, assuming that's what they mean, I'm definitely gonna need more paper for these two. gonna take up a damn tree right there. Well, actually, I didn't get a lot wrong, technically. Oh, never mind. That first section really threw me for a dupe. That's fine. Once I come back and do this on a separate sheet of paper, I really don't want to do it now, if I'm being honest. I really don't want to. But you do what you gotta do, boys. Oh man, I really don't want to. How about keep this on transition? Something new. But that's fine. Let me see what else there is. Cause that's all the questions, the exercises. There's 5.1 approximating areas, and then there's the exercises for 5.1, which is what we've been doing, which is literally all of these, which is crazy. But I only did like, yeah, I didn't do too many of them. Okay, what I'm gonna do is go get a sheet of paper. Now that I understand how to do these, I'm gonna go back and you can't even, you know, I think I'm noticing you don't even know what's going on. Why the frick is it like that? Holy mother of pearl. It's whatever. It's like so over, and I want to do a, oh my gosh, what is that? That's balance. I think it's white balance. No, it's not white balance. That's like warm tones. This is like, oh my gosh. It's like, I think it might be, if it's not over saturation, I can't remember what it's called. Color grading, that's what it is. Yeah, that's like what's it called? But the issue I'm having is it's color correction, color grading. I'm just about to ask ChatGPT. Well, that's Wolfram, but exposure. That's what it is. Okay. they say. So I don't even think I have exposure on here. I have gain though. Oh shoot, my gain is like, let me see. Wait, it said like 0 to 30, which is low-key crazy. Oh shoot. Come on. That eats though. Okay, that eats. Okay, that eats. Alright. Shout out ChatGPT. Okay. But like, what do I look like? Am I darker too? No. Alright, it's fine. It's good. Like I'm not already dark, but brightness. So I might kick the brightness up. Yeah, like that. But then I can like lower the gain. Yeah, that's fine. I can always kick brightness up. Okay. We should be able to. Oh shoot. Yeah, that should be good. Gain might have to. Yeah. Let me make sure. Yeah, it's not perfect, but nobody is. That's way better though. White balance. Woof. They said what? 4,000 to 50,000 K. Woof. That is warm right there. This is like regular, and then it gets cooler. This is like Twilight. I think that's good. This is like killing my eyeballs too. Alright, yeah, that's good. At least now you can see more of what I'm doing. Or what I've written. Good. Thanks, ChatGPT. Oh, I can like permanently save them. Add a... Yeah, freaking glare and junk. This is good though, I'm not gonna lie, I like the way it looks. No, ChatGPT, you've done your due diligence. You're good. Thank you. So I actually need to go look at this and see because I don't even remember the stuff that I said I was gonna do today now. So. I briefly remember it, and I'll kind of go based off of that, but I don't all remember. Alright. So we're gonna redo the equal or non-equal. So this is oh my gosh, my dog is acting a damn fool. Okay. I hope I was muted that entire time, but alright, that makes sense. 1, 2, 3. Okay, so yeah. This is looking a hell of a lot better. Yeah, this is a completely different answer already. Alright. Okay, I got it. Shall we do... So then I know this one is wrong too then, huh? I can probably just redo this one right here. Okay, it moves by 0.5. So for the right hand, where are the intervals? Okay. So we start at 0.5. So yeah, it's a completely different answer too. That's okay though, as long as I get it right. That's honestly what matters most. Alright, I'm probably gonna do 21 just because 20 doesn't have an answer, so I would just rather do 21. Okay, so we have intervals, our f of x's. So that means our change in x is oh, God bless me. Change in x is equal to 1, thank the Lord. So what I'm thinking is it's probably gonna be I'm thinking we're gonna have to take the positive and the negative of the same function. So I'm thinking like, oh, this is the positive. So it's gonna be like 3 minus 3 minus 0. Or sorry, I just said positive and then I wrote negative. Plus 0. It's gonna be 3 minus 3 plus, what are we, left side? So I just counted 5. 1, 3 minus 3 plus 2, 3 minus 3 plus 3, 3 minus 3 plus 4. Okay. Now I'm thinking that's for the positives. And then for the negatives, we do 3 minus 3 minus 0, 3 minus 3 minus 1. And then we basically do an equal sign like that. And we calculate. So 3 minus 3 is 0. So this is basically 0 plus 3 minus 3 is 0 plus 1 is 1. 3 minus 3. So you can kind of see where this is going. Okay, that's going to be 10. Just kidding, it's 20. Because 9, 10, 11, 12, 13, 14, 15, just kidding, it was 15. That's so funny. Okay, this one, 3 minus 0, still going to be 0. Or wait, am I tripping? No, I'm not tripping. 3 minus 3 is 0, 0 minus 1. So negative 1. 3 minus 3 is 0. 0 minus 2. Make sure, yeah, I'm not tripping. Negative 2. There's a pattern there. Whoopsie. Okay. And this should be same thing, but negative. But here's the thing, they told me to Compute their average value. Absolute value is like a, so the same things that it has on the left, same thing that it has on the right. Oh, they do? Okay, so they mirror each other. Oh, it's midpoint. Okay. That would give me 0. Ouch. The hell is that? Oh. Oh, it's left 6 and right 6. Well, yes. Assuming I get 0. Yeah, let's change an X. Yeah. 0, 1, 2, 3. Oh. Wait a minute. How the hell? 0, 1, 2, 3, 4, 5. I'm confuzzled. Oh, so they just did that? Oh, so they just took the... Oh. Wait. Because what did I have for the left? Oh. That's how this is a 2, isn't it? Yeah. Okay, so this will be 3 minus 1. 2. That makes sense. Okay. So then we get 9. So then that should mean for the other side we should get should get 3 minus 3 1. Wait. -3, but then it becomes a +3. It becomes a 0. Does it not? Oh wait, yeah, because you can't have a negative. It's absolute value. They have to mirror each other. So 1, 2, 3, 2, 1. Okay, 0. Okay. Oh, that makes sense. Let me see if I can plot this. Jesus, that's bright. Because if I did 3, what was it? 3 minus the absolute value of 3 minus x. Oh, sure. Like that. We get something like this. And then the area, like they said, under the curve is just, let me see if I can do, can I do 0.5 base times height? I don't know if I can do triangles in this one though. Can you even do triangles in? Technically, I feel like you could make a triangle. Like, for instance, let me take this out. Like, let's say it was just this. Technically, you could do, what point is this? You could do, like, x equals 0, or sorry, you could do y equals 0, and then you could do a line at x equals, let's do like 100, and there's your triangle right here, and then it's 1/2 the base times the height. I wonder, could we shade this area in? Maybe not. I know Desmos has some really, really cool stuff in here as well. Is it geometry? It's in there, geometry stuff. Oh no, this is, okay, whatever. Alright, that was, damn, sorry. Slammed that junk hard as hell. Alright, back. So, I think, so I went back and redone. Put the date on this. What are we in, June? No, we're in May. No, we're in June. I'm tripping. was a good review though. Hold on, let's check my cellular. Okay. Might go do lunch now. I'm not gonna lie, it's like 10. And then I'm probably going to. Okay, I want to just keep doing math. I'm not gonna lie, because now we get into definite integrals. I wonder what our homework. What are the exercises for this? Express limits as integrals.
You're not gonna believe what
Oh,
tell me everything. I'll show you on Monday.com. So I started the big.
My goodness. There's no way. There's no way they just gave me a double ad.
Gym Monster 2 is an
No way. No way. Alright, taking the limit and goes to infinity.
With the Amex Platinum card, you have access to over
Oh, why do they
$1,500
give the
in
answers?
total
Oh wait,
value,
no they didn't.
with
Good.
benefits across travel, entertainment.
Okay, I don't think we're gonna start here. I think we're literally, or I think we will start here. I don't think we're gonna really go through this for real. We might though, but he already put in an email to review this. Oh my gosh, you sub. Yeah, I have a lot to do today, I'm not gonna lie. Yeah. Honestly, a lot more than I thought I would have to do, but it's calm. It's calm before the storm. Sample test. Oh yeah, the homework. So this would just be 1 over 2x times dx. And that's the homework. And then when does that due? So what do you do on Thursday? Yeah, this class moves quick. I might just start doing the homework. And then immediately U sub. Alright. I know what must be done. Because he's gonna go fastest boy. And I need to learn U sub. So yeah, hold on. Okay, let me see. Alright, I'm gonna watch this video while I eat.
So, what do you do?
I think that's the move.
What do you can't speak.
Okay.
In this video, I'm going to show you how to integrate using use substitution. So we're going to focus on definite intervals. How can we find the antiderivative of 4x times x squared plus 4?
Alright, so this is what I'm about to do. I'm gonna get something to eat. Then I'm going to do U sub. Then we can start transitioning from U sub to more. I'm probably gonna do the homework. I'd like to get ahead on the homework. I'm not gonna lie. I don't know how he wants us to submit the homework. I'm not sure. And I need to start some physics work too. My class isn't until 2:30 tomorrow though, so I mean. Alright, I'll be back. I'm gonna go get some food. Ooh. Should I? Oh shoot. Oh no. We are miraculously on the DoorDash. Oh wait, let me not dox myself. Sorry. I surely was about to type it in too. Oh my gosh. Can you? It's whatever. What the freak? Oh my lord. It might not. It may not be meant to be. Actually though, I literally just freaking forgot about my DoorDash subscription since like college. And so I was like, who the hell keeps charging me $10, dude? But with them, I could never be mad. Ooh, dude, Moe's sounds really good. Arby's, we have the meats. I shouldn't do this though, should I? No, I shouldn't. Dona arepa. No, I shouldn't do this. Oh, that's my cue. Yeah, I'm not gonna do this. I'll find something else to eat, but it's not gonna do that. Okay. BRB.
In this video, I'm going to show you how to integrate using U substitution. So we're going to focus on definite integrals. How can we find the antiderivative of 4x times x squared plus 5 raised to the third power? So what do we need to do? We need to define two things. We need to identify the u variable and du. Now, whatever you select u to be, du has to be the derivative. If we select u to be 4x, the derivative will be 4, and that's not going to get rid of x squared plus 5. We need to change all of the x variables into u variables. Now, if we make u equal to x squared plus 5, du is going to be 2x, which can cancel the x in 4x, and that's what we want to do. So let's set u equal to x squared plus 5. du is going to be 2x, but times dx. So what I'm going to do now is solve for dx in this equation. So if I divide both sides by 2x, dx is equal to du divided by 2x. Now what you need to do is replace this with u and replace the dx with du over 2x, and it will all work out. So let's go ahead and do that. So we have 4x, and then u raised to the third power, and then du divided by 2x. So here we can cancel x. 4x divided by 2x is 2. So it's 2 times the antiderivative of u to the third. Using the power rule, it's going to be 2 times u to the fourth over 4 plus c. Now 2 over 4 is 1/2, so it's 1/2 u to the fourth plus c. The last thing you need to do is replace u with what it equals, and that's x squared plus 5. So this is the answer. Let's try another problem. Go ahead and find the integration of 8 cosine 4x dx. So what should we make u equal to? We need to make u equal to 4x. du will equal 4 dx. And if we divide by 4, du over 4 is dx. So let's replace 4x with u, and let's replace dx with du divided by 4. So this is going to be 8 cosine of the u variable, and replace dx with du over 4. So now we could divide 8 by 4. 8 divided by 4 is 2. Now what is the antiderivative of cosine? The antiderivative of cosine is sine, because the derivative of sine is cosine. So we have 2 sine u plus the constant of integration, c. Now let's replace u with 4x. So the final answer is 2 sine 4x plus c. So hopefully you see a pattern emerging when integrating by u substitution. The key is to identify what u and du is going to be. And once you figure that out, you just got to follow the process, and it's not going to be that bad. So let's work on a few more examples so you can master this technique. Let's try x cubed e raised to the x to the fourth. So what should we make u equal to? X cubed or x to the fourth? If u is x to the third, du will be 3x squared, and that will not completely get rid of x to the fourth. But if we make u equal to x to the fourth, du will be equal to 4x cubed, and that can get rid of the x cubed that we see here. So let's do that. Let's make u equal to x to the fourth. So du is going to be 4x cubed dx. And then, as always, solve for dx. If you don't do that, you can easily make a mistake. So I recommend, in this step, isolate dx. It'll save you a lot of trouble later on. So dx is going to be du over 4x cubed. Now let's replace x to the fourth with u, and let's replace dx with du over 4x cubed. So this is going to be e raised to the u times du over 4x cubed. So x cubed will cancel, which is good, and the 4, we can move it to the front. Now, because it's in the bottom of the fraction, it's 1 over 4. Now, the antiderivative of e to the u is simply e to the u. So the final answer, well, not the final answer, but the antiderivative is 1/4 e to the u plus c. And now let's replace u with x to the 4th. So this is the final answer, 1/4 e raised to the x to the 4th plus c. And that's it.
Join a growing number of professionals who are advancing their careers with a graduate degree from the top.
Here's another one. Find the indefinite integral of 8x times the square root of 40 minus 2x squared dx. So typically, you want to make u equal to the stuff that's more complicated, and that is the stuff on the inside of the square root. If we make u equal to 40 minus 2x squared, du is going to be, the derivative of 40 is 0, so we can ignore that. And the derivative of negative 2x squared, that's going to be negative 4x dx. So isolating dx, we need to divide both sides by negative 4x. So it's du over negative 4x. So let's replace this with u and this part dx with du over negative 4x. So it's going to be 8x times the square root of u times du divided by negative 4x. 8x divided by negative 4x is negative 2. And I'm going to write that in the front. The square root of u is the same as u to the 1/2. So now we can use the power rule. 1/2 plus 1 is 3 over 2. And then we could divide by 3 over 2 or multiply by 2 over 3, which is the better option. So negative 2 times 2/3, that's negative 4 over 3. Now the last thing we need to do is replace the u variable with 40 minus 2x squared. So the final answer is negative 4 over 3, 40 minus 2x squared raised to the 3 over 2 plus c. And that's all we need to do. Let's work on some more problems. Feel free to pause the video and try this one. Integrate x cubed divided by 2 plus x to the 4th raised to the 2nd power. Now typically, it's better to make u equal to the stuff that has the higher exponent. 4 is higher than 3. So let's make u equal to 2 plus x to the 4th. Du is going to be the derivative of x to the 4th, so that's 4x to the 3rd power times dx. And as always, I recommend that you solve for dx, just to avoid mistakes. So let's replace 2 plus x to the 4th with u, and let's replace dx with this thing that we have here. So we're going to have x to the 3rd on top, u squared on the bottom, and dx is du over 4x cubed. And if you do it this way, as you can see, the remaining x variables will cancel out nicely. So this 4 is in the bottom. Let's move it to the front. So it becomes 1/4 antiderivative 1 over u squared du. And so let's move the u squared from the bottom to the top. So this is going to be 1/4 integration of u to the negative 2 du. And now we can use the power rule. So if we add 1 to negative 2, that's going to be negative 1. And then we need to divide by negative 1. So now let's bring this variable back to the bottom to make the negative exponent positive. So it's negative 1 over 4u plus c. Now let's replace u with what we set it equal to in the beginning. So I'm going to need a bigger fraction. So u is 2 plus x to the 4th, and then plus c. So this is the final answer. let's integrate sine to the fourth of x times cosine of x dx. So go ahead and find the antiderivative of this trigonometric function. So if we make u equal to cosine, du will be negative sine dx. That will only cancel one of the sine variables. And it's best to make u equal to the trig function that you have more of. We have 4 sines and only 1 cosine. So it's best to make u equal to sine x. And du will be equal to cosine x. And since there's only 1 cosine, this will be completely canceled. Solving for dx is going to be du divided by cosine x. And don't forget that last step. Always isolate dx. So let's replace this with u. So this is going to be u to the fourth times cosine x, and dx is du divided by cosine. So we could cancel cosine x. And so we're left with the indefinite integral of u to the fourth du. Using the power rule, 4 plus 1 is 5, and then divide by 5. So we have 1/5 u to the 5 plus c. And the last thing we need to do is replace u with sine x. So it's 1/5 sine raised to the 5th power of x plus c. And that concludes this problem. Now, what would you do if you have to integrate the square root of 5x plus 4? Now, in this problem, all we could do is set u equal to 5x plus 4. There's nothing else that we can do. So let's go ahead and do this. The derivative of 5x is going to be 5, and then times dx. So isolating dx, it's going to be du over 5. So just like before, we're going to replace 5x plus 4 with u, and dx with du over 5. So then this becomes the square root of u, and dx is du divided by 5. And move the 5 to the front. So this.
All right. It's a yummy lunch. Not sponsored. That'd be kind of fire to be sponsored by kombucha. Kombucha is like healthy Sprite. I mean, this junk feels like it literally is burning your gut. Jeez. Okay. We have to find the antiderivative using the indicated substitution. Okay, so here's my thing. Like, how should I submit my homework? I think I'm gonna do it on paper. I think we're gonna do it on paper. And I think this should be chill after watching like 10 minutes of Yusa. I'm just gonna do it on a blank sheet of paper. I'm gonna make it as neat as I can now. So I'll put okay. All right. 261. So you've got the integral of x plus 1 to the 4 times dx, and u has to be x plus 1. Okay, well, we know if we have u equals x plus 1, then du is equal to 1 times dx. Therefore, dx is equal to du over 1. Yes, I'm going to be exaggerating about it. Alright, so now we can substitute in and have u to the 4th times du over 1. We can then proceed to take the integral or take the integral of u to the 4th times du over 1, and we'll get 1/5 u to the 5th times du. We can then do 1/5 x plus 1 to the 5th times the original du, which was, actually I don't think we do that. I think I literally just put plus c. Oh, sugar. Let me just get to the end of this. I think I literally just put plus c. Yeah. There's my answer. All right. What is that, -6 now? So now it's like 1/6 u to the -6 times du, which is going to be 1/12 to x minus 3 to the -6 plus c. Let me back check that. Alright, so we add 1, we get a -6, so we take that same -6 and put it underneath. Oh, this should be a negative. Yeah, because, oh, but wait, no, that's why I did that. Because whatever, no. because, let me reason. If it was a negative 6 plus 1, but see, when you put it in the denominator, let me see. Thank you. When integrating, I'm just gonna make one up. I think it's, no, I think it'll be negative. Yeah. Okay, so it is negative. Let me actually just write out all my steps down. So then I basically said, okay, I'm gonna take 1/2 multiplied by a negative 1/6 times u to the negative 6 times du, and I got negative 1/12 u to the negative 6 times du. This can be put back in its regular form of 2x minus 3. Say negative 1/12 the negative 6 plus c. Okay. Fire. Oh my eyes. Good grief. Okay, use a suitable change of variables to determine the indefinite integral. Well, what the hell do you mean by that, eh? What the hell? I think now I'm picking my own use of variable. Hopefully that's what this means. Actually, just in case, that is exactly not what that means. But like a okay, integral of t squared times cosine of t cubed times the sine of t cubed. I'm gonna make u equal to t cubed, so du is 3t squared times dx. Oh wait. Alright, bet. So then we get dx is equal to basically 3t squared divided by du. Just kidding, opposite way.
Pixar's Elio is the best Pixar movie in years. And Pixar's best original since Coco.
It's really happening!
One of the studio's most poignant films.
I want to go see Elio. Okay, anyways. Okay, then basically we can do 1/3 on the outside here. And then we have was that a T-squared? It is. So we have am I tripping? No, it's derivative of T now. I'm sorry. So it's not dx. It's with respect to T. Okay, but I'm only substituting in for my u's. So T squared is cosine of u times du over T squared. Now these can cancel out. Now I have now we can take the integral. You're gonna get sine of u cubed at that. I don't know why I dropped that. And then sine is cosine. Cosine is a negative sine. What is this? Sine. I think this might be a negative cosine. Times du. And we've established that du is just du now. We're gonna make sure I got this right. Because sine is cosine. Cosine is a negative sine. So if we're going backwards from a positive sign, it's going to be negative cosine. Now, is it a chain rule? I'm thinking it might be a chain rule, but I'm not sure. I think it is though. So it should be cosine t squared times 2t. But they would just all be together. Oh, and then it's inside of a product rule. Yep. Alright. So then, what did that 1/3 belong to, the du? Okay, so then we do. So yeah, it's sine of u cubed times 3u squared plus, or no, it would be minus. Cosine of u cubed times 3u squared. Wait a minute, I just took the damn. Jesus Christ. I don't know if it applies the same. We're taking the integral though. just gonna give it other things, but it was t squared times tangent of t cubed times secant squared t cubed times Okay, that's what I need to know. So for the integration, okay, so tangent squared, this is a standard form. Wait a minute. Oh, so they just kept it on you. Okay. So they just kept it as u and then took the integral. So the t squareds cancel out, yeah. Then you have 1/3. Ah, okay. So I didn't even need to rewrite anything. That was good right here. Okay. So then I could just say that the answer is yeah. 1/3.
This is a story about a magical place where everything's amazing, especially the people.
I have no clue if that's right, because low key, I just confused the crap out of me. Let's see here. That I've done the problem, I can check and see. Oh, so this is a trig interval. Or integral, excuse me. You're not hearing it twice. I'm so sorry. I just thought about that. Damn it. I think it'll be okay though. Okay. Oh, what the hell? A standard trig integral? I know cosine or cosine squared of x plus sine squared of x equals 1. V sub, so if v is equal to sine of u, then dv is cosine of u du. Okay, well. Alright. Let me try and figure this out. But what is the trigger identity? This is the one that I'm aware of. So it must be that, Okay. So I guess we need to set v, what they say, v is equal to sine of u. So then dv would be cosine of u. So then dv would be cosine of u times du. Yeah, because then we can say du is equal to dv divided by cosine of u. So then I think we would be able to sub in basically like v times, that would now be a v times dv. No, I think it'd be times, I don't know what the flip this is. Oh, because it's cosine of, that's what I said, cosine of u du, so then du would be oh, so then it would just be, oh, okay, wait, that's what I did. So we would get, yeah, v times dv is equal to v squared times basically dv. I don't think dv would change. Yeah, it becomes a c because it's a definite, or it's an indefinite. I haven't even gotten to my programming stuff, Jesus. Plus c, which can also equate to 1/2. It's like this, so now it's 1/2 v squared plus c. So now we substitute all of that back. We have 1/3 times 1/2. And our v was equal to sine of u. So now it's sine squared of u plus c. So plus c, which then becomes 1/6 sine squared t cubed plus c. And then come on now, just make music. Okay, I did a second substitution. Now watch how the entire integrand transforms. So now we set v equal to sine of u. So now the derivative of v dv is equal to cosine of u du. The original cosine of u times sine of u. Under this, now sine of u is v and cosine of u is dv. Oh, because the derivative. Okay, I think I get it. So it's the same thing, because this is v and this is dv, and this is what we're taking the derivative with respect to. So when we integrate this, it basically kind of gets rid of this. Interesting. It transformed into dv. I absorbed it into the differential. Why would I want to do that to myself? No. Like what? Okay, 281. Well, now I know about that. Alright, 281 is the integral of x squared divided by x cubed minus 3 squared times dx. I'm going to make my u x cubed minus 3. So my du is equal to 3x squared times dx. So then my dx is going to be equal to du divided by 3x squared. This means when I put all this in motion, we get 1/3 the integral of actually I'm gonna wait because so let's do the integral, and it'll be x squared, which stays, over u squared times du divided by 3x squared, and these should cancel. And then we're left with, now we can put the 1/3 integral of 1 over u squared. Or we can bring it to the top. I think I could just bring it to the top. Of u to the -2 times du, which this will, I'm so freaking like particular about this shit. Okay. Add 1, we're gonna get a -1. So then this just goes back to 1 over u times du, which is 1 over 3u plus c, which becomes 1 over 3 times x cubed minus 3 over 1 plus c. That one was not bad whatsoever. I don't know what the hell was going on 280. Problem 280. Freaking junk was liquid crack. I don't know what the hell that was. Junk threw me for a loop. Alright, and then the last problem is 282. Which is the integral of x cubed yeah, this one's gonna be simple too, because u is just gonna be 1 minus x squared, so then du is gonna be
Lily, my hero.
oh, just kidding. Damn it.
My daughter was diagnosed.
What's up, Willie? Okay, that was so freaking. I should have done 3, or I should have done x cubed. So I should have did u is equal to x cubed, so then du could be, no, I thought I was on something. I'll stay with what I've got with my 1 minus x squared. Du is gonna equal, we can cancel out an x though, so I think it should be okay. So it's gonna be x cubed divided by square root of 1. X cubed divided by square root of u times du over x. So then we get the 2. And this cancels out completely. So then we have a negative 1/2 u to the x squared times, I guess you could say this is really a u to the negative 1/2 times du. Take the integral of that, and you get, because I don't think you take the integral of everything, x squared times, 2 u to the positive 1/2 plus c, which will give you negative 1/2 okay. I feel like I'm doing so many things in my head at once. Okay, so there's no integral. I don't think there's no integral anymore. I'm not sure if I was supposed to take the integral of this, but I don't think so. Excuse me, I think it was just supposed to stay the same. Well, positive 1/2 and then it flips, so it becomes x squared times that. And then we get basically a negative 1/2 times 2. 2u to the 1/2 times x squared plus c. We get a negative u to the 1/2 times x squared plus c. We get a 1 over, oh no, the thing is negative, but the exponent is not, so I don't have to do that. So I could just say it's a negative 1 minus x squared to the 1/2 times x squared plus c. But I want it to be cleaner. Okay. Hopefully I was right. the what the actual brick is this? Oh, so I should have substituted in the form of everything should have been in the form of U. So then I should have said that, okay, that would mean that x squared is equal to 1 minus u. And then I could have separated this into x times x squared. So I got this part. It was just this back part. Oh, wait. Oh, okay. No. I'm not. I probably got like 50% of that. Or 75% of that problem wrong. So this is what I did, and I did it like that. Let me see if I could have done there's no way.
Thank you for your interest in conducting an
There's no way. There's just no way. So we would have a negative 1/2 with a 1 minus u with a square root of u times du, because we just cancel these out. So then from here we could integrate, and because this is no different from having like a negative 1/2, and then you have a 1 minus u squared. What is that? So now you have a positive 1/2 times 1 minus u, which is now squared, being multiplied by a 2 over 1 u to the 1/2 plus c. But bear in mind that Oh, wait. 2. Sorry. I was like, what the freak? This should have been a 3. And I would have made this, because that would have been a 3. Now it would have been 1/3. And then, this originally belongs here. So we can do, or should we just keep it, because that's a -1/2. Wait, I'm getting confused, but I think I understand. Because if that's a 1/2, and it was originally a part of, so then this would be like this. This would be 1 minus u squared, but then it would be multiplied by u to the -1/2 times du, and then that would mean that would be 3 1/3. So then we would have, did we distribute that -1/2? He integrated, I understand that. I know, actually I kind of don't, because yeah, it's x squared plus x. Okay, now we know. Okay, so I should just keep this -1/2 back here with this du. Heard you. Got it. Wait, but Oh, so that means the whole x squared now equals that. That makes a lot of sense. So now this doesn't have that. And now this is okay. Okay, that makes sense. So now this is the part where I should have separated them. So I should have done 1 over square root of u minus u over square root of u then I could have taken the integral at this point now. Yeah. Because u is 1, so when you have 1 minus an so then we get that's 1. So then we bring a 1 minus a negative 1/2, or is it positive? It should be negative. So 1 minus, what the hell? Okay. So we brought everything to the top. I don't know, because when you have 1 minus a negative 1/2, because you brought it from the bottom of the fraction to the top, I'm low-key like, how is it positive? Both of these should be negative. Oh, I think I see where they did the 3/2. Yeah, I seen that. So it's just 1 minus the 1/2. So there's oh, they just evaluated it like this, not bringing it up to the top. Okay. Makes sense. Okay, then we can take the integral, right? Then this would become a negative 1/2. Oh yeah, integrate. And then that would be a yeah, okay, I know how to move forward. So now we do the integration of -1/2 of u to the -1/2 minus u to the +1/2 times du, which is going to be equal to the integral 1/2 of +1/2 to the bottom, so it's going to be 2/1 u to the 1/2 minus 2/3 u to the 3/2 times, well, we can just put plus c, which is going to be, now we have -1/2 multiplied by 2/1 times the u to the 1/2 minus 2/3 u to the 3/2 plus c. This is going to give us a, or actually, it's like this because it gets distributed. So then we get negative u to the 1/2 minus 2/6, so 1/3. It should be a +1/3 though, yeah. 1/3 u to the 3/2 plus c, which brings us all the way back to a negative 1 minus x squared. Oh, but they chose to put it in the square root. I see why. 1 minus x squared plus 1/3. You really could do this and put it in the 3rd root. Oh, maybe you can't. Just kidding. I thought you could put it in the 3rd root. Maybe it's because there's so many exponents and things going on. Plus 1/3. 1 minus x squared. I don't even have freaking room for all this. It's getting low. Okay, plus 1/3. 1 minus x. 3/2 plus c. Okay. That was interesting, but there's my homework. Holy moly. Let me get this off my holy crap. What the hell? Oh, no. Pollo Tropical is so good. Never mind. They can talk about whatever they want to talk about. Holy moly. Let me see. Alright, now I have to, do I want to do the other one? The other one should be simpler. It's, yeah, this is upper bound and lower bound. I really don't want to do it, if I'm being honest. No. I'm gonna do, but I will create a page for it because I'll do it in like a second. Oh. Ouch. This is okay. And I'll do that in a second. Now we're about to get into programming because I've been doing math for damn near 5 hours, which is beyond insane. What am I trying to do? Oh, I'm about to do this, but I like doing it on my iPad. But I'm about to do my brewing.com. I think I'm just gonna like finish all these. Algebraic reasoning, and then I'll do real world algebra. Let me see. Yeah, I'll do like all of these, almost all of these. And then, I actually have a good bit of stuff to do, I'm not gonna lie. Hold on. Yeah, I have a good bit of stuff to do. Now that I think about it, and I'm supposed to, hold on, I'm supposed to call somebody, but oh, that was so nice. what's gonna happen with that, but I need to. I really need to see what I. Okay, here it is. I didn't even do partial integration. So that's that on that. All right, bet. So I still have to do my linear regression project. It's okay. I said I'm gonna get it done. I'm gonna get it done. It's only even looks like a 12-hour stream to me. Maybe. It really just has to be research papers. It doesn't have to be deep learning. All right, let's do it. I'm gonna just keep my thing up and right there so I can see it. Okay. It seems so childish, but it's so freaking fun. Good. Oh my gosh, it's so fun. It's like a mental break, but like I'm actually doing something, but it doesn't feel like it. It's so far. The goal is like a 365-day streak. I did not see that happening. it not be 20 squared if it's the first 20 counting numbers? Oh. Isn't that like 20 factorial? Oh, hell no. I don't think that's it. I don't know. Let me see. Yeah, I don't know. Oh, I didn't mean to do that. Okay. Oh, I should have squared 10. Yeah, that still didn't make much sense, I'm not gonna lie. What the hell? Okay, let me make sure. My whole number. Okay, I got 8. And then Oh, what the hell number did I choose then? Oh, I multiplied by 2. That's so funny. Jesus. Okay. 10, 20, 28, 27. What is the number in their head after they add 2 to it and then multiply by 4? If they add 2 to the number, like, what? Wait. Didn't they just say add their favorite number again to the new total, to the current total? Not gonna lie, I have no clue. Yeah. What the hell? I'm goofing right now. Get this shit off. They must be talking about the number that it currently is. Yeah, the current total. Okay, well you keep saying the favorite number. The favorite number is the original number. No, I didn't mess with that one. I don't know. I could just be butthurt that I got it wrong though, you know. I'm not doing that no more. I'm gonna take a break. Because that just made me a little bit more upset than it usually soothes me. It didn't soothe me that time. Actually, I'm gonna move to my coding. Did I not send? Oh no, I did. I probably just didn't keep it myself. Okay. Yeah, now I gotta do some programming. I really need to finish my vector project, but I'll get that done too. It's all good. What did I say I wanted to do? Oh, I gotta fix my plan. I think I might do that. Because I need something that's not like cognitively like demanding. Okay. Bruh, I'm trying to like, but it's okay. This is why I kind of prefer doing it on my own computer, but oh, you know what though? No cap, I just thought about something. I might just be able to do that. Because if I wait, let me look this up first. No. Apparently I need a capture card. Oh, I see what they're saying. Oh, this is that real streamer stuff right here. Yeah. No. Okay, well, not gonna lie. I don't know how else to, what's it called, unless I freaking wear the camera. on my shirt, but it's just so difficult doing it on here because it doesn't have like the scroll function that the Mac has. It's trash. Wait, I want to check something. I'm trying to get some, well, I'm not trying to, I will get them, but some AirPods Max, but Jesus, man, they're so expensive that low-key, in my head I'm like, do I really want to run my pockets like that? Like, let's be honest. Do I really want to run my pockets like that? And the answer is yes. The answer is absolutely yes. But still, like... Oh, wait, they have them. Oh, it's online only. And they're still freaking $550, dog. So, what's going on? Oh my gosh. Do I get a discount? Oh my gosh. I'm gonna cry. I'm freaking cry. I'm crying. When I did the tax and everything, it was like $587. I just I let out a sob. I was like, there's no way. There's no way. But it's what I want, so I don't give a damn. I also want to get a standing desk, but I'm gonna wait. But I just want to like improve the setup. Like I feel like the camera already does so much. But you know, I want a bigger desk. I feel like if I showed you I mean this part looks clean, but my desk isn't messy, but just it's so small, and I want to like stand and do work and stuff like that. So we can take like a break for like 15 minutes. I really don't give a shit. I want one of these, like a flexi spot. Oh, okay. Oh, I didn't know. Oh shoot, that scared the bejeebies out of me. All right, I'm back on, boys. I'm back on. Oh. Alright. Yeah. Ow, my knee. Oh my gosh, I didn't know they sold like actual furniture. I low-key want to, I mean, there's nothing wrong with my bed. She's right there. But dude. Yeah, I want to get one of these because I don't have a lot of stuff on my desk. And then what I probably would also do is I'm definitely gonna build my own PC so that I can do just some more. That's literally gonna tip you out the recliner. What the hell? Oh, something like this would be fire too, but I don't know if I'd be able to do that because I have my like desk drawer over here, or my like clothes dresser, and I'm not sure that would work. I think it'd be fire, but I don't know. I think it would kind of take up too much space. I have a lot of space to work with though, for sure, but I think it may take up a little too much space. Maybe not. Maybe I'm just tripping. But yeah. Oh, what's the sale? $289. Of course it freaking ends tomorrow, so I could be impulsive. Oh, this is fire though. But I don't know if I don't want like a rolling desk though. need like an office chair. Oh, it starts July 1st. Yeah, so this is gonna be like $420. Lol. It's gonna be like 5. See, but I don't need anything that's like right. Actually, this desk does have double, what's it called? But I think it should be fine. Again, I don't put anything like heavy on my desk. It'll be my monitors, and then I definitely want to get. Okay. I didn't know they sold this much stuff. It's like Muji, like everybody, or not everybody. I think that's absolute, but I initially knew Muji for just pens, but like they sell everything. They're not just stationery. Yeah, I just want a standing desk. I was gonna get one in college. I'm really glad I didn't because I don't know how the hell I would have got that back here. I would have been so pissed if I would have had to leave that into storage. But I really like this one. It's $289 too, which ends in 15 hours. But I'm not gonna do it. I'm not gonna do it. But this one's fire too. I don't really like this one. I feel like I don't have enough room to write. I don't know if you've seen, but I don't write like with paper that's, you can't even see, straight up this way. Like I tilt it to the side. So like having enough desk space is really important to me. That's why I'm more so looking for a desk that's wider more so than longer, because I already plan to optimize for space by getting some monitor, literally just like that, some monitor arms. So freaking sit in my chair and bike the Tour de France. Okay, yeah, that's what I'm thinking though. I don't know yet. Yeah. I'm not sure. Yeah, and I don't want an L-shaped. I changed my mind, I think. Maybe I just do... But maybe not. Maybe. I don't know. I don't know. Low-key. Honestly, I'd be chill with this. But like, how much weight can it hold? I'm not putting anything heavy on there, but at the same time, if it could tolerate a little bit of weight, that'd be great. I like the way this looks now. But yeah, I probably want something like that. I'd probably go get like some, is it Etsy? I think it is Etsy. Yeah, like this is just, like, how quirky is this? Like, what the hell is this? Like, this is some stuff I'd put on my desk. Let me see what else. Ellen Riley. A resin of John Wick. Sylvester Stallone. Walt. Severus. You know, I don't really talk about like myself. I just kind of like sit here and do work, but I freaking love Harry Potter, dude. Freaking Morgan Freeman. Who's ordering these things? Dude, he's in every damn movie, and he's always. I don't know if I've ever seen him in a movie where he's not like the bad guy. Oh, my dog's about to act the. Dude, I want like a Stephen King one. That'd be fire. This is actually fire. What other like 3D printed stuff can you get? Harry Potter, the guy who drove the bus. I think his name's like Murney or Ernie. Oh, that's tough. What? I don't know if it's real though. I don't know, boys. But I like that type of stuff. Or like tech for desk. I'm not even sure what that means, but yeah, like stuff like this. Like that. Like this. I like little quirky stuff. What the freak? A floppy? Oh, I didn't know it does that. Like it creates more tabs. Dude, I've wanted one of these for a while. Like a PCB pencil holder. I think that's so cool. That's fire. Yeah, these are so cool. But yeah. I think little stuff like this is awesome. Yeah, I think that's awesome. It's probably what I would do. What is this? Hold on. Come on. Nope, hold on. Nope. Alright, back to the grind. At like 12:30, I'll get back to work. I'm gonna take a break. This is fire though. But yeah, stuff like that is really cool. Or I think anything that's just like super techy. Like right now I'm really into bookends. Yeah, like that's fire. Or like that one's pretty cool. These are so awesome. I've seen a lot of people do these. So cool. Oh, this one's cool too. Oh, that's fire. I might watch Pulp Fiction. Actually, I'm really trying to get into watching more movies. I guess just like taking more breaks, you know. But alright, bet let's get back to the business. Alright, I'll just do it on here. Whatever. Okay, wait, hold on. I'll be back. I gotta do something quick. Alright, let's do this. I don't know how much time I have. Well, I'm not clicking off the stream until I finish everything I gotta do. But, okay, let's see here. So, here's the dilemma, because if this is, I guess, my journey, I'm just learning Python basics, so I haven't learned C. So actually, this and this. This would be what I'm doing now, basically. So that can get deleted. This can get deleted. That can get deleted. Basically, I've learned. Okay, I see what I have to do. So data structures and algorithms. Whoa. Go. Like that. But both of these can go over here. And this math and stats. Oh wait, and this conditional physics can go over here. So I learned Python. Actually, you know what? I might just do it like this. No, I was gonna turn it, but I'm gonna leave it just how it is. I have to think logically now about how I want to structure this. So I'm doing Python basics now. After that, I'll probably go into learning about data structures and algorithms. But at the same time that I've learned, put that up there. At the same time I knew I was gonna do that. Oh my goodness. At the same time, I've gone ahead and learned, so my math and the Python should be lined up because I learned them pretty much at the same time. So I should probably be learning data structures, linear algebra, Calc 2, classical mechanics. So this would actually be like that. Actually should be lined up with that. It should be maybe like XL. Like that. Oh, it's because this is the next one. Oh, it was. Okay. Then. Okay, and then I didn't mean to do that. Take this to here. Take this to here. And then take this. To make sure it lines up with that, yes, but yeah, but line this up in the middle. No, I wanted to be in the middle of my Calc stuff. That's okay. I feel like I know how to maneuver this, but then I want to here into basics. I Python basics into data structure and algorithms. Okay. So then the foundational physics can actually come up so that it's eye level with these. And this line can be like this and like that. And then this. No. Oh, let me do it like this. Is there a way I can, I guess make this cooler? I mean, like, oh, I know what people have done. You know what I can do? I've seen people take a topic and they take a node and they make it blank. And then they like make it bigger like this. And they push it to the back like that. And then they push it. Okay, they must be on the same level then. Pull it to the front. Yeah, they do something like this. Guess not. So then what is it? I'm confuzzled. Cause it's not. Oh, there it is. Okay. Okay, well. See if I can put them in the middle of all of these. Well, that was good. Make this like pink. Cause I'm a girl. I might make all the lines black. Oh, okay. Never mind, I don't want to do that. Okay. I low-key, you know what I wanted to do? Like a black. Oh, but then that can't be. Well, that sucks. Okay, then I'll do like a gray. That's fine. Okay. So this is what I want to do. And then we do, yep, programming fundamentals and basics, which is going to be data structures and algorithms is what we're going to next. And this will be at the time that we do linear algebra calc 2, which, yes, that means right now. That's why this is so important for me to get done today, because class starts tomorrow and I need to find courses. So not only do I need to revise this plan, I also need to find courses for data structures and algorithms. And I need to find a course for, actually I'll just say find course for the following. Actually, no, yeah, that's fine. So I need one here. Algebra, of course. I need okay. Mathematics. What did I do? Alright. Bet. Whole lot of stuff to do. So I'm low-key hungry. Actually, that's cap. I'm not hungry. I don't know when I'm going to get into C, but right now I'm in Python and I really want to master that. So what I might do is push everything down a bit. Secondly, I'm learning Python basics now, so I might not do data structure and algorithms, and I may just do that when I get to Calc 3. Make sure everything is lined up. I don't know how far out I'm gonna do this either, so I'll be doing modern physics, Calc 3, and I need some other math. I have my class schedule. I'm supposed to be doing proofs, so maybe I do proofs. Yeah, maybe I do proofs. I showed it briefly yesterday, but my class schedule is intro to proofs, intro to diffie-q. That's actually it, but I thought it would be way more that I'd be taking. Perfect. And then intro to proofs, which is so what do I have here? I have linear algebra. This is so tiny. I'm so sorry. I don't need this. Okay, so I've got linear algebra, Python for right now. Calc 2, start that tomorrow. Classical mechanics, start that tomorrow. I'm also doing probability and statistics right now, but I think I might hold off on that, but I'm not sure, because that's super important. What I might do is I might push linear algebra down, but I don't know. Then we can do Calc 3, ODEs, and real analysis. So then what I'll do I low-key, what in the world? Oh, okay, I low-key want a little bit of light. Okay, bye. Thanks, but I didn't really want you to make the roadmap. It's fine. Linear algebra, vector spaces. Okay, discrete math, intro to proofs. Okay. So maybe I will, let me move this tab over. Again, you know what, it's okay. I know what they're trying to do, and I'm just gonna, yeah, so linear algebra, discrete math, so I need to make one for discrete math. Okay, that's fine. Okay, Calc 1, Calc 2, linear algebra. algebra, physics 1, physics 2, E&M. Okay. So I gotta do physics. I'm currently in linear algebra. So Calc 3 should be with modern physics, which I think it is lined up with modern physics. And then after linear algebra, we can do discrete math and proofs. Well, let me see, I didn't even check. Okay, discrete math. Logic and proof techniques, set theory and functions. Oh, let me move this out the way. I don't need it. I gotta low-key lock in. Hello? Let me zoom in. What in the hell? So it should be taken with Calc 3. And there's E&M. Wait, so where did modern physics go? Oh, so I should take modern physics then. Oh, because I'm a wee bit behind. Right. Well, this is gonna be fun. I'm just gonna be a bit behind then. But, statistics. Can move up there for the moment because we gotta get E&M. Because E&M needs to be up like that. This is so freaking like, I don't even know how to move over there. Oh my gosh, I figured it out. Okay, thank you, Jesus. When I needed the Lord the most. Okay, so after that we go into E&M. It's definitely not what I wanted to do. Go into E&M, and then now we've got Calc 3 ODEs. So after this is ordinary. Jeez, okay. Oh my, oh my. Okay. It's looking pretty good, not gonna lie. So now we've got, I'm actually gonna bring this down a bit more so that it lines up. There. Okay, so what's happening after discrete math? Now we get into real analysis. feel like this one is slanted. Okay. This is location. Okay. Now we're in quantum mechanics 1. Wait, what happened to thermo? Am I tripping? What happened to thermodynamics? Well, it seems like I'm gonna be pretty busy with this, so I might, what is that? Modern physics, discrete math. What I might do this said I can do 2, right, at the same time? Before or alongside quantum mechanics. Yeah, I'm supposed to be doing quantum mechanics. So real analysis, and then it's supposed to be abstract algebra 1. Let me just continue on and see what's what. Well, this is math. Math is still mathing right now. Right now I'm doing double math though. I could bring it back in like this. But I think I'm continuing to take 2 maths. Abstract algebra and complex analysis, yeah. Okay, but oh, I think I see what they're saying now, but I don't think I'd take this in the same year. I think they'd be in different semesters. Okay, bet. Okay, perfect. What in the world? Hello? What in the hell was that? Okay. Holy moly. Okay, let me see. So that's that. Oh, sugar. Alright, but, I guess what I'll take like that. So that's complex analysis, that's abstract. Should be quantum mechanics in my, and I can, they said, oh my lord. Holy crap. I can take, so then what I'll do a split. So we can bring this down further. Bring this down further. Actually, I just probably could have brought it off to the side a little bit more. Like this. And then I could have done like this. Quantum mechanics would have been here. I could have did that one. You know what sounds really good? Subway. Wait, these are off though. Like these. Yeah. See, and then it's laws of thermodynamics, wave force. Okay, bet. I think it looks cleaner if it's like a bend. Yeah, I saw better. Okay. we'll see what I do for programming, because I think that's like all the way down here. And then this quantum error correction, I'll see. Well, there's DiffEq. When the hell was I supposed to take that? Oh, there's DiffEq, ODEs. That's right. There's ODEs or PDEs, partial or ordinary. That's fine then. Basic principles, quantum information theory, and quantum computing, algorithms, error control, error correction. Okay, now we gotta get into machine learning, deep learning frameworks, data cleaning, model deployment, reinforcement learning. Yeah, it doesn't seem that bad actually. So then, after that, we go into quantum mechanics 2, real analysis 2, measure theory. Can I copy all this? Is that even possible? I don't think so. Okay. Put slash measure theory. Four nodes. Oh, so this must be, okay, so this is. Okay, I might stop there. But then, what is this? Real analysis. This is the year I should also be taking. I might. Okay. After that, I probably can get into quantum information theory. So then we can do something like, probably sever it there. Do something like this. And then bring it down, put it in the middle as best as I can. And then do, I don't know why that did that. Actually, if that's the case, and bring this to this. Why does it do that? Okay. Oopsie. I think we're pretty good. Probably stop right here, because that's a lot. But it's a pretty good plan. I need to figure out the programming piece of it. So. Okay, now let me see where I find that. Hold on, 'cause I might actually need to move this over. Okay. Okay, I see. So I need to get into holy moly, I know that's loud. Okay. Well then actually, oh no, that's right, because this is where we're at. Yeah. Okay, good. Alright, fire. We can actually delete some of these because we touched on them. Some of these down here in the deep learning section. Yeah, like basically all of this. Deep learning. Okay. Deployment, data engineering, cloud computing, DevOps, computer architecture, databases, time series analysis, computer vision. Okay. I think that's good, I'm not gonna lie. Okay. I think what I'm gonna do is I think this is good. Anything else is pretty far away right now. So this plan is pretty decent for right now. The C basics we can bring it down here. We can kind of put everything like this would be far over here. This deep learning stuff. No, not all of it though. Small deployment, feature engineering. This deep learning stuff would be like over here. Feature engineering. So it'll also be like over here. All deployment, cloud computing, this. All this can like be in its own spot until I delete it later or I utilize it. Not sure yet. But I know for like right now, I definitely have more than enough to deal. Damn it. I low-key want to delete it, but I'm not sure. I do. Put that down there. Something is over here. Oh, deep learning. Yeah. Okay. Take that up. And we can probably get into this like during this time. Or really just right after. So actually, yeah, let me see if I can line it up. Sugar. Oh, whoopsie. Okay. Once I finish this, I'm gonna probably do my math homework and then I don't know what I'll do after that. It looks really good though. I'm not gonna lie, I'm quite, what the freak? Oh, I'm quite proud of this. Like, this is low-key tough. Oh shoot. Who the frick? Well, that probably means statistics in here. Okay, well then, I'd actually probably do this. Not gonna lie. Should I put it right here? No. And it all depends. Some things can definitely shift up, and so I'm guessing this means this has to like shift down. But I don't see. Hold on, I gotta figure this out because it's got to yeah, okay. Yeah, this is really good. Fire. Okay. Let me see. We've been streaming for like 8 hours. my homework. 1.4 homework. Alright. Because it's literally due until it's due on July 3rd. Class starts on Monday. It's due on Wednesday. So I'm just gonna, you know. So this is square root of x minus 1 over. Oh, wait. Okay. I think so, because negative 1 over 2 plus 2 over 2 is 1/2. 1/2. Yeah. Okay, so that's my answer there. And then 208. shoot, I didn't mean to do that. So I have to use usub. It seems to literally be the same exact rule.
It's easy to.
Okay, that makes sense. So is that the natural log? I think it's just gonna be the natural log. Can you have that? I think you can. Especially when you're dealing with the exponents. Yeah. Oh, plus C. Okay. That. Okay. Should I use sub? Oh. Is this the same thing? There's no way. Maybe I won't use you stuff. This is just, what's it called anyways?
Sometimes think.
Okay, but that's what I did. Alright. Okay. Now we gotta evaluate it from B to A. So, that's from pi to 0 or sine of x minus cosine x times dx, which is going to equal to integral of sine negative cosine, sorry, negative cosine x we love a definite integral. Oh, fire. Alright, that's what I got. Okay. I think it's just one more. Yeah, which is pi over 2. I'll just go in the back. After this, I need stretch. Holy moly. So the integral is going to be what in the heliante? What the heliante is this? The hell's that? I gotta figure this out. Pi squared divided by 8 minus 1. Okay. So, or I could have wrote it like that. Pi over 2. does. Let me see, cause and what was pi squared? Oh my god. How did you even get to this? Like, oh, I see, pi squared. No, I see now. Because that's pi squared there. And then 1/2, that'd be pi squared over 4 right there. And then you add 1 to that. So now that's basically what? And cosine 0 was 1. So maybe that's where it came from. Because you add 4 over 4. I don't know. That's interesting. I'm not gonna put that on. What the hell you on today? Well, my homework is done. Homework's done. We're almost there. Ooh. I thought my programming would do. It's only 2 p.m. No way. It's crazy. Alright, let's go find some courses for me to do for when I start tomorrow. Yeah. Save. Okay. Alright. Homework done. Probably staple these two together just to keep track of them. Okay, let's go find some courses. This should be fun. So I need courses for linear algebra. I already am in Calc 2. I need linear algebra, classical mechanics. I already found my classical mechanics course, not gonna lie, but oh, I have not had vector algebra. Let's see. So I gotta do 3 lecture sessions a week. The first one being 2 hours, and the second one, third one is an hour per session. Three in-class exams, a final. "34 lectures, and they go through what, 3 a week?" Oh. It's like a 3-month course. Really, you can take that one off. Interesting. I low-key want a more contemporary physics course. These are all, but I guess, does it matter? Maybe not. Sorted by date. No. Oh, this is a class. I'd love to take this. What the freak? Oh, frick yeah. Oh, you write a paper. I might do this one too. Why not? Statistical physics, quantum physics 3, quantum information science, quantum theory, classical mechanics 2, classical mechanics. Oh, it's 12 weeks. Okay, bet. I might do this one. It seems to be the most recent, up to date. Yeah. Yeah. Alright. Well, I think I found my class, so. Now I'm gonna take this link and put it over here. .01 SC. I low-key need ChatGPT to make me a schedule too. Title. If I can get it done in 2 to 3 months, that'd be ideal. If I can get all, well, I don't know why I put course for 2 to 3 months, but it's, again, I probably should have put this. Okay, good. And then if I have anything else, I'll put it in there too. But okay, what does this show up like? Well, that's pretty cool. Oh, so it must show up in the live view. So I'm like, it's not showing up right now. Where's the thing? Okay. Empty content? So it's in progress too. We did not learn gradient descent. Or is that what optimization is? Maybe we did. I'm confuzzled though because I just put this stuff in there, but remove. I'm just gonna put the same description they have in here. Whoa. Yeah, that works. Perfect. Oh my god, it's something on my screen. What the hell is that? That's so interesting. Okay. So that's that on that, which is great. I'll keep that up. And then I really kind of low key want to do this one too. But we'll see how my time looks. Okay, now I need to go get a linear algebra course. Oh, the one, the only Gilbert Strang. I mean, oh wait, there's two of them. There's SC and then there's, oh, okay. I'd probably be better off doing this one. Okay. Well, I'm gonna do Gilbert Strain. So, actually, let me do this one first. Okay. That's that on that. I think that's it. I think. Because Calc 2, linear algebra, classical mechanics, Python basics. Yeah, I think that's it for what I'm doing here. Let me pull this down. It's not. Okay. With that being said, I think that's it. Okay. Well, let me see what else I've got. Now that I have basically completed that. Oh, data structures and algorithms. I think I already have a course for that. I could do Code Academy for that. Let me see what they're. Oh, and I have my thing tomorrow. It's my quantum to QML, quantum mechanics. Yeah. Okay. Yeah, advanced integration by parts. Let me look at a sample test. Okay, that should be it. Classical mechanics. Now I kind of need to figure out how I'm going to schedule all of this within my life. Or that's what I was gonna do, hold on. Because Code Academy has I low-key just want to finish Python 3. Oh, 50%. Jesus. Should I just start from, even though these are optional, but classes, files, dictionaries, which I actually do know what dictionaries are from Brilliant. I just have strings, modules, and dictionaries. I think I should start planning. But anyways, they have a 75 hours. But yeah, this data structures and algorithms course. I also have math and computer architecture and stuff like that. But yeah, they've got linear algebra. I completely calculus. They've got discrete math, probability, simple linear regression, binary basis. You can read, you see it. Okay, then, yeah, I need to plan this. My class is every day, Monday through Thursday, 2 to 4:30. So, how am I gonna do this? And I work. I work as a financial analyst, I work right now, which is super fun. So, I kind of gotta get, oh shoot, make sure I'm doing that, because, I'm gonna have to start planning. So, we found this course. I'm just gonna do Code Academy's version, not version, but their actual course. Where'd the roadmap go? Okay, now I'm good. Okay, so this is completed. I still gotta do integration by parts and read like 2 to 3. Is this loud? I still gotta do integration by parts and read like 2 to 3 papers. Yeah, pretty much. Okay. That's fine. To review the content, I think the simplest way is to use W3 schools, in my opinion. Just for me to get my feet wet again. So, just literally to go through all the exercises. Oh, I can just do this. Oh, this is perfect. I'm just gonna start here and go forward. So I took a break for like a week, and then I just came back. Ooh, I think this one is like that. Yeah. What time is it? Okay, it's like 2:30. Oh shit. Maybe it was that one then. Ah. Create a variable named car name and assign the value Volvo to it. Where's the camera? This is a joke. You're right, because you know what? It was a string. Oh, I think you could do this. Oh shit. I haven't done this before. Yeah, so it's equals that you can do. You just said that. Oh. Just kidding. So I was right, but when there's multiple variables, that's when you can use commas. But when it's just like one variable, I guess that you want to assign the same content to different variables is when you do x equals y equals z equals. Is it because the comma's there, it gives it a space? My apology. My bad. Okay. Let me lock in. The global scope. I actually have no clue. Oh, global. Yeah, no, I had no clue. I usually just declare it outside the function. Should be fantastic. I should have overwritten the also now. This is a double, but like how do they, or this is a float, I'm sorry. In Java it's a double. This would be this is a list, or this might be an array. I don't know, this is a list. This is a tuple. Oof. Oh. I don't know about this one, Pimp. Okay. X into a complex number. I have no clue. Let me reference my book. Oh, Python? You can't use it. It's Python crash course. Okay, let me see here. Okay. Integers, floats. Okay, that didn't help. And you did not help. Oh, you could just put complex. Wow. I was unaware. Oh shoot. Why did it just do that? I don't even remember where it was. I had already done that. I'm probably at here. Oh my, I think it's gonna be 35. I think it rounds down. What do they want? 2 because it's inclusive. 5 because it's exclusive. So 2, 3, 4. Yeah. I actually sucked at that. Like literally not even a week ago. Like this junk to me was like, what the frick is this? That just goes to show patience is really of the essence. Patience and time. Dude, I was supposed to call somebody, but like when I tell you my hello? It was so funny too because I was supposed to call them and I was like, oh okay, like yeah, just give me your number, and they're like, oh yeah, you can call between this hour and this hour, and I was like, oh, okay. And I was like, again, like you have my number, but how the hell am I gonna call you? And like they never responded, and it's like 20 minutes until the time, like till the time window ends, and so I'm kind of like, well, I mean, I don't know what to do. Okay. Yeah, I don't know. But, okay. To print a string uppercase, I think it's all the way like this. Oh shoot. So it's just 2 upper? Oh. So it's just upper. Oh, okay. Okay, that's good to know. I didn't know that. Oh, the book, I literally just seen this in the book. Okay. Apparently it's oh, hold up. Oh wait, no, it's wait. Actually, it would be. Oh, actually, it's both. So it would technically be, which makes sense why they only allow so many characters. I don't even know if it's append. Maybe it is append. Append. Damn. Okay, let me see. Replace. Okay, I was close. So it was replace. Okay. Oopsie. That makes sense. We're merging the variables. I feel like you could do this if they're integers, but it's a string, so I'd probably say something like, oh, okay. Oh. Yeah, because you can add 2 strings. I just seen that in a prior quiz that we did. Yeah, so it'd be, but with no space because it's not a comma. put space. F. It's like this. I have no clue. Let me see. So I guess I would just do like X like that. Okay, thanks. Oh, where did I get X from? Because I was looking at I was thinking of the prior problem. Okay. It's okay. I was on the right track. The only wrong answer is the one you don't give. Correct. I love Booleans. Print the Boolean of ABC. It's 50-50 chance here. The hell does this even mean? Well, they just said false, so somebody's lying. Somebody's lying. What will be the result of the following syntax? X equals 5, now it's plus 3. Operators actually want operators, booleans, and functions are like what I love about programming. It just seems so concise and just satisfying. If I complete this, then I'll count that as my increased proficiency, because I've already reviewed the content. Okay. What will be the result? No way. Print my list one. Banana. What will be the result of the following syntax? List items cannot be removed after the list has been created. I think that's true. I thought that was true. Or is that a tuple? No, I think that's an array. I think that's an array. Yeah, oh, that's Java. Yeah. Okay. Select the correct function for returning the number of items in the list. Oh, it's, yeah, the one function. Which will be the result of the following syntax. My list is equal to bang, bang, bang. Print my list. It's gonna be cherry. print the second item in the list. So print fruits 1. What will be the result of the following syntax? My list is equal to apple, banana, cherry, orange. You're a bit loud. Print 1 through 4, not including 4. So 0, 1, 2, 3, not including 4. So banana, cherry, and orange. Use a range of indexes to print the 3rd, 4th, and 5th. So zero, 1 should still be banana. Change the value from apple to kiwi. Oh, just kidding. Okay. What will be the result of the following syntax? My list is equal to apple, banana, and cherry. My list is equal to 1 and 2 are gonna now be 0 and 2. Are now gonna be kiwi and mango. Print 2. But if this doesn't include 2, then 1 is the only one that changed, maybe. So then this should still be cherry. Okay, she said no, it's mango. Okay, good to know. My list, apple, banana, cherry. Insert at 0, orange. Print 0, 1. I can't remember who scoots over. So at 1, I believe it may be apple. So, fruits, append. I don't think I have to do anything special. Select the missing parts to add the elements of tropical to fruits. So then we would do fruits. Oh, I've not seen these before. That's append. Okay, extending. Okay, concatenating. So it looks like dot join is winner, winner, chicken dinner. Okay. Fire. Never seen that one before. Removing list items. I think it's pop. Yeah. Am I using the word remove or am I popping it? See what I'm saying? So there's remove and there's pop. So I guess interesting. Let me see. What will the result of the following syntax? Okay, apple, banana, cherry. So pop banana out. And then print the list. So it should just be apple and cherry. Fruits. So then we would need to remove all. It's either delete or clear. I feel like it's clear. What is the correct syntax for looping through the list? It's like for X in. What's the difference between these two? Oh yeah, it's this one. The semicolon. Or the colon, not semicolon. Oh. Is it if? If I is less than. No. What the freak? Oh. Let me see. While I is less than the length of my list. Okay. That makes sense. Oh, list comprehension. Oh, it's gonna be print. Oh, how did it go? No, I think it's like this. Oh shit. Why is it in, was it always in an array? I can't remember. But I know the action comes first, like what you wanted to do. Now it's list comprehension. What will be the value of the new list? X for X in fruits if X is equal to banana. Oh, what's it called? Print it. Fill in the missing parts to complete. Okay. X for X in fruits. What will the value of the new list be? Apple for X in fruits. Are we looking for apple in fruits? Oh wait, no, I think we, oh, okay. No, I have no clue what this is then. This is beyond my current scope. If we have X for X in. Oh, maybe we just keep printing apple. Oh, okay. I thought that was it. I thought it was reverse equals true. Maybe it's -1. Okay, well, this is new. My list reverse. So if you want to sort, you sort. But if you want to reverse the current order of the list, oh, we're not worrying about sorting anymore. Okay. Now, if we're sorting it by descending, now reverse is equal to true. Correct syntax for making a copy of a list. Maybe it's this. Wow. What is the correct syntax for making a copy of a list? Oh, so this is another way to do it. I feel like you could also just put it into another variable as well. Okay, they said hell no. Okay, so you declared a new variable list, and you set it equal to, well, I guess you typecast it as a list, and you put it as list 1. Or whatever your list's name is. Okay. So, I'm assuming you could also, I can't remember what this one does when you don't put anything in there. I feel like you should be able to do this one. Oh, okay. I just don't feel like it's this one because that means you're going in reverse order. For joining list 1 and list 2 into list 3, you'd probably do list 3 equals. Yeah, I feel like you could do this, or you could do this. Oh, okay, well then it's gotta be the join function. Well. But you just said prior to that well, maybe we didn't have to typecast it. Okay. If I want to add elements, maybe I join it. I feel like if I extend, let me look it up, but not look it up. Let me search it so I can see it. So you can use an extend. Okay, so it's best for me to use an extend. For X and list 2, so 1, 2, 3. Take list 1 and append X. So it should be like, okay. Yep. You know what? That I don't understand. Because for X and list 2, I'm thinking every time that we roll through, if you will, or loop through this, we kind of like place this in there. Every time we get to 2, we place it in B. 3, place it in C. Oh, but we're appending it. I'm sorry. I'm a fuddy-duddy. That's on me. A tuple. This is a tuple. So wouldn't it be the length function? Tuple items cannot be removed. I don't. Yeah, they're mutable. Okay, where are we at? Holy crap. That's actually crazy. Wow. We're pretty far, actually. Okay. Am I tripping? Okay. So now I've done this. I'm pushing this to tomorrow. I think that's it for me. I've been doing this like almost 12 hours. So Alright. You can, this will probably be my, I guess, last few. And then you can access tuple items by referring to the index number. What is the index number of the first item? Okay. Oh my gosh. That was so much. Alright. That was a lot. I'm not gonna lie. That's probably the most I have ever worked. But I honestly think it's attributed to when a camera is filming you, and even if nobody is watching, there's always the possibility that someone's watching. That really like will motivate the shit out of you. So I'll continue doing this for sure. It's accountability. I can't like sit up here and like be on bullshit because somebody's watching. Okay, let me exit out of everything. Alright. Boy, that was a lot. Alright, I'm out of here. I don't even know what time I'm gonna stream tomorrow. Probably at like 4. No, I'll probably stream at 5 again. But then it'll probably be like a shorter stream, be like 4 or 5 hours max. So, alright. Be blessed. Don't stress. Give it to God. I'll handle the rest. That was a fire outro. That was fire.